So this is an update and a little bit of historical perspective on Galaxy. This is a typical Galaxy presentation because we just finished making slides. And I think some of the people who will talk, they don't know about this yet. So I hope they're here, just to make sure. Like, is Pira here, for example? Okay, so then I can present South Africa, no problem. This is the second GCC in France. The first GCC in France was in 2017. It was in Montpellier. And for that GCC, one of the asks was to have a little presentation on Galaxy history. So this talk combines two things. We're going to talk about history a little bit. I have about 100 slides to go in about 15 minutes, so I'll do that. And then we're going to do community update. But before we do that, I just want to tell you that we're not a very young project. So unfortunately, we're losing people as well. And I just want to emphasize the people that we lost over the years. It's James, JJ, and Simon, and they all made incredible contribution to this, of course. So you all know that. I just want you to remember them. And you all know about GXTX Foundation, and if you can help us by promoting this more, because we need to be able to raise more funds and so on. So we're trying to keep this alive. Okay, so this is essentially a verbatim copy of my Montpellier presentation on the history with some additions. So I'll go through this quickly. But I think it's important sometimes to know Galaxy, to know the history of things. It's not like, it doesn't really help you to predict the future, but it just makes things a little bit more interesting. So Galaxy actually existed before 2005. But the story of the whole thing and why Penn State got into all of this is sort of interesting. And I thought that at the time in 2017 that Asterix would be a good way to illustrate that. So once upon a time, there were three guys. They're not here, but they're actually all alive, thank God. It's Ross Hardison, Webb Miller, and Gene Myers. Some of you might have heard about them. And two of them, so Webb Miller, Webb and Gene, they are pure computer scientists. They didn't have any interest in biology whatsoever. They were essentially working on some text processing algorithms, how to sort things. It's a very interesting problem. And perhaps about 1980, they become tired of sorting things, ABC. That's what computer science is all about. And how do you sort things quickly, right? 0.01 second win. So they got tired of this, and they walked to the office of Ross Hardison, who was a professor at Penn State at the time, and they asked him, "Hey, Ross, is there anything interesting in biology?" And Ross, of course, says, "Of course." And he was studying globin genes at the time, and he was always studying globin genes. So he was aligning things, essentially. And this is essentially how BLAST, all the alignment algorithms that we use today, pretty much started, because this was Webb inspired by Ross, and this is how all this worked. So they look like this. They're a little bit older now, but they generally look like that. And this was early 2000, so this is human genome was just sequenced. There was mouse, rat, chicken, all that good stuff. And people were trying to align them because the main question, this is before next-gen sequencing. This is before all of that. So at that time, the big data were alignments, because when you align human to mouse, you get millions of blocks and you need to do something with them. This is actually an interesting problem. We still don't know how to deal with that properly. I mean, we do, maybe in this auditorium, but biologists at large, they have no idea, they have no tooling, and they have no way of dealing with multiple genome alignments. This is actually a very good subject for us to, and we're working on that as well. And so the galaxy is actually the etymology of the word galaxy. It comes from the word gala, which was, I still don't know how to deconvolute this, but I think it's a genomic alignment and something, whatever. So you can try to redact. I'm very bad with abbreviations. And you can see that on that author line, there's nobody who's here. So this is origin of galaxy. It comes from that paper. And that's again the Ross. He's a true hippie, still is. And essentially what Galaxy was, it was a database with alignments, and you were able to ask queries about this. For example, where genes are, how my SNPs overlap with promoters, and so on and so forth. And essentially, the origin of the Galaxy logo, you know, that strange set of 3 lines, that was that symbolizes genomic intervals. That's the origin here. And so at that time, so yeah, this was the general architecture of Gala. If there is one guy who knows this well, you can ask him. It's Dan Blankenberg, who's somewhere here. Where are you, Dan? Over here. Good. So, and it was a 50,000 line Perl script at the time. And this is the time when I came into Penn State, and Ross was trying to fund it. He was trying to write a grant. He wasn't succeeding at that, so he gave it to me. He's like, okay, here's this thing, try to write the grant, ha, ha, ha. And I needed to write grants because I just came there. I didn't have grants. And, you know, you survive in American academia only if you generate numbers, which means grants and papers. And this was, so initially, the idea was to add more tools to this 50,000 line Perl script. And well, I'm going to skip through a few things. And this is actually was the first, so Dan was the first person who actually worked on Galaxy. And we decided, oh, this is a good set of tools called MBOSS. I don't know how many hundreds of command line utilities was there. So we just asked Dan to wrap this thing, and then we left. After about 2 weeks of complete silence, we asked Dan, how are things going? And he said, I'm on letter P. So if you, again, for those of you who don't know MBOSS, look it up. It's a collection of command line utilities starting with letter A, B, C, so there's lots of tools. So he was at letter P, so there was some progress. And as I skip through the slides, at that time, a person who made some important engineering decision was Istvan Albert. You probably know BioStar. So he was a part of that operation at the time. And then James joined. And so at that time, it was, of course, completely re-engineered. It was completely Pythonic. And in fact, early configuration of Galaxy was using YAML. So XML evolved later. XML was added to that later. Of course, then we had this thing and we needed to promote this. And one of the, I think, key decisions for us was hooking up with UCSC. This is Jim Kent in Switzerland, probably. So Jim Kent is the person who, well, who helped to assemble public version of the human genome and who also wrote UCSC Genome Browser. And because there was this long-standing collaboration between Penn State and Santa Cruz, essentially Penn State was producing alignment tools, and UCSC were running them and displaying the results. That was the partnership. So it was relatively easy to achieve that, and really all that did is added this checkbox right here. So send to Galaxy, and you know, unsuspecting people were clicking on it. And this is how it all kind of, and when Ryan was talking about Logan yesterday, I'm trying to do the same thing to Ryan, basically, is that I'm trying to bring Logo into Galaxy because then unsuspecting people will start clicking on it and we'll get even more users. But of course, Logan too. And then the flood started. This is the first next-gen paper. This is 454 paper in 2005. This is when people completely forgot about alignments, completely forgot about genomes per se, and started basically sequencing shit out of everything, with sometimes not a very clear idea why. But it was a kind of a good moment for us because we're starting plugging in all these tools. So this series of slides shows you the evolution of Galaxy interface. It still kind of looks the same, but it had a blue phase. Well, the first phase was really this. This was actually the interface. Peter, thank you for coming because you need to present that slide, by the way. So yeah, good. So this is the blue phase. This is so-called lavender phase. And it was before workflows. And this is 2007. So I think this was one of the Cold Spring Harbor meetings. And so this is when this is before any workflow languages. So this and again, that didn't change much, at least visually. Well, it changed a lot, but visually not that much. So again, current interface looks more like this. And then in early 2010s, there was this cloud thing craze. There were new money coming from Obama administration. Life was good. And we had this Cloudman project, which Anis can tell you a lot about. This was an interesting time when the thinking was, we don't want centralized servers like .org, .eu, .au, .fr. We actually want people to run individual galaxies. And so one of the ways to do that was instantiate your own thing on the cloud. And that was again the logic. The logic is that there will be lots of galaxies. Eventually we realized that it's going to be a maintenance nightmare because everybody who will be installing Galaxy will be calling us that it doesn't run on their particular hardware. And we only have, each of our instances has only one NAT equivalent. So it's very difficult to scale that. And then we had another problem is that we're starting wrapping all these tools, but tools have dependencies. So how do we deal with dependencies? How do we make sure that people install things? And of course, Conda and Bioconda helped enormously, but before this all happened, we made a mistake of creating Toolshed, in which we were trying, well, that's not a mistake, but it was an interesting engineering challenge because we tried to write essentially our own dependency management system, which we still suffer from in some extent. But John, please scream at me if I'm saying something incorrectly. And of course, Bioconda now and biocontainers became the integral parts of all of this. And Toolshed really triggered the creation of IUC, and IUC is one of the best things in this ecosystem in this community. And again, if I don't see my tools, approved by Matthias, I don't know. I don't think they're good. So how it came to France is a little bit. I don't actually remember exactly how this happened, but we had this idea to do, Tour de France. It has a strange destination. It started in Perpignan, which is actually a very nice town. And then sort of through Lyon to Paris. There was a lot of interesting things happening during that time. But so I don't know if you know Alban Larmin. Am I pronouncing this correctly? Larmin? Okay. So he was the power behind this. He worked in Institut Curie and he organized all this, and he drank a little bit too many La Choufs. So this is actually, I think this photo taken maybe actually in June, and you can see that they're wearing scarves. So it was not hot. This is also, no comment here. So at that time, when we had this Tour de France, it was all running off of the so-called main, although I want to apologize for using the term Galaxy main, because it sort of somehow assumes that, US instance is the best. Please refrain from using it. It's .org, .eu, .fr, .ca, all that stuff. But at that time, that was the only thing. And we had a big rain. And our server room was on the 5th floor. So somehow, actually, I think, Nate, correct me if I'm wrong, but I think all those histories are still there, right? Yes. So it actually, miraculously, it didn't damage anything. But this was also, and yeah. Ask me during something that involves beer, probably, about this episode. But it's true, actually. I had to write an apology, an official apology. But this actually helped us a little bit because, well, it helped us big time because we realized that we can no longer sustain this thing at Penn State. It's becoming too, there's too much use. And one of the manifestations of that is that we could not scale. So people were deleting jobs before they were starting because they were just waiting for too long. There was one guy who was saying, I forgot his name, that when you start a Galaxy job, it's a time to go chop wood, because apparently he was maybe heating his house with this sustainable method, and but this was not a good PR thing for us. And at that time, Texas Advanced Computing Centers stepped in, and this is one of the very important steps in our development. So now our main in the US, our main hardware providers are Texas, so Texas Advanced Computing Center, and Jetstream, which is at Indiana University, which hosted one of the GCCs, but it's not listed here because it was not originally in 2013. And so this is how we established all this infrastructure. In 2014, we created collections, which sometimes are still hard to explain, but I think collections are key to making Galaxy scalable for large analysis. I think it's one of the best things about our UI. And I cannot help this with this slide, because it's just, since I'm from Soviet Union and we, for some reason, in our troubled history, we have a lot of bearded individuals. So some of them here, this is Mendeleev, you know, the father of the periodic table. And then, of course, this is Marx and Engels. They didn't do anything for Galaxy, but they screwed up sort of the history of that continent. And then there is Chilton, who didn't screw up anything, but he just created Planemo. But he just fits into this. I'm not trying to pick on him. It's just he fits into this line of portraits very well. And then the bad times started. So the COVID hit, and for COVID was a kind of a good thing for Galaxy in a weird way, because it was an ideal platform for doing surveillance and for pushing new tools for processing millions and millions and millions of COVID samples. And this is what Freiburg and us did very successfully at the time. But of course, actually, James's death had nothing to do with COVID, but then that happened on April 2nd, and that's probably one of the most traumatic events in my life. And then Mike saved the team by essentially taking James's group, and I'm doing this ever since. And just imagine that somebody dumps this on you. Like you have a group, and now suddenly you're becoming responsible for this. So thank you, Mike, for this. And I think he completely saved the vibe. Nothing changed, and this is incredible. So in terms of community, some of you might remember Ross Lazarus. He's from Melbourne/Sydney. He somehow he learned about us. I don't know how. I don't know. So he's the first. Galaxy community at that time was me, James, and Ross. That was the Galaxy. So he was the first community outsider. He taught us how to write grants, because he's the most cynical individual I know. So he basically explained to us, when you write a grant, it's fiction. Just write it as a book. You do something else later, but just write it as a book. So think of New Yorker articles, you know, like Shouts and Murmurs. If you read New Yorker, there's this funny section in every New Yorker magazine issue. So just think about this. Make it funny. Make them want to read this, because all they need is the first page. Very wise. And he also suggested having a conference. So the first conference was essentially a product of his idea. You guys need to have a conference, and you need to write a grant to get that conference rolling. We wrote an NSF grant, got 50,000, and organized the first Galaxy conference. He also said that we need t-shirts. And some of you still have that t-shirt. I know Bjorn for sure has the red one. It's the most historical one. And then it was not necessarily politically correct time, so you could do t-shirts like the yellow one. And then for the What Would Flying Spaghetti Monster Do t-shirt, that's the fourth one here. I was accused of the fact that I don't respect religious freedom here. So we kind of cancel that one. But if you want to see t-shirt number 3, talk to Hans Rudolph. He was walking in it yesterday. And here's the Hans Rudolph. He was the first European. You know, those strange people across the Atlantic that embraced us. And then, of course, Galaxy P, which is also represented here. This was it was incredible because it was the first thing which was not associated with Penn State in any shape or form. And they just took it and they ran with it, and we had nothing to do with this. So this means adoption. And this is the first conference, and it's not a very high-res picture, but you can recognize some people, and it's actually remarkable. Well, anyway, we can. And then there was Bjorn, of course. So Bjorn is strange in a way that you commit something, and then he doesn't merge it. He just complains about it, but he complains about it in a strange time, right? So let's like 2 a.m. there, no? Right now, he's not here. I don't know if many of you know why, but he has a good reason not to be here. But he still is there with his phone, and he still tells me that I don't respect this or that, and that I need to talk to whatever before I commit this, because I'm gonna piss half of the community. So thank you, Bjorn, for keeping the worst instincts out. So I just want to finish with saying this project depends on the community, and with what's happening in the world right now on our side of the world, but eventually will probably be happening on that side of the world too, there are different ways to resist that. And I think the goals of this project in making, so there's this idea which I used to write in my grants. I'm not going to do this now, but I'm still going to continue doing this. It's called analytical equality, because most of the analysis happen in well-endowed labs with a lot of money. But what's for the rest of us? And so I think this project tries to fill this, and that's priceless, and that's our way of resisting. So let's continue doing that. And now the real update, so I think Mike will start.
Okay, thank you, Anton. That's always really fun to reflect on the history where we came from. Okay, so we're going to talk a little bit. So that was sort of the past. We're going to talk a little bit about the present, and then a little bit about the future. So I really wanted to have a shout out to Michelle, who's been kind of curating the sort of dashboard of all the known active instances. We're currently up to 111 and counting. So we can't possibly tour every single one, but wanted to give just a couple of cross-cutting updates from some of the major instances and some of the major groups here. I also wanted to have a shout out to Ennis and others that have been sort of plugging in activity from all the different instances into this one sort of key usage indicators dashboard. So across just a handful of the 111, we're 714,000 users, to 200 million jobs, 370 million data sets, approaching 1 million workflows that have been executed. So I think this is just a really nice summary of all the activity with, on the order of 10,000 new users just registering every month. Just incredible activity, incredible growth. What an incredible community of people that we have right here. So next up, we're going to tour through some of the major instances to hear about some of the updates, and we'll kind of hand it off to Gareth to kick it off from down under. Thanks, Gareth.
Thank you, everyone. We always look forward to this part of the talk because it's really nice to actually compare the ways we use Galaxy. I'm also a little humbled that I think on my first or second slide, I'm now showing something that Anton showed nearly 20 years ago, but we're excited. So things we've been doing in Australia. For those of you that know, Australia Galaxy is run under an organisation called the Biocommons. They pride themselves on really deeply engaging with user communities and defining a user community, hopefully, best practice, a user community that has money. So this is some slides about communities that have money. So things we've been really proud of, and I'm going through stuff with mostly active. So this is not a retrospective on the last 12 months. These are all in train work. So we got our community lab paper published. That was awesome. That is the Galaxy Labs engine. That tells you how to build a lab. We're currently iterating that so that you can really just put in a series of tools and some text, and Cameron, who's lead author on that, has created a local LLM model to build a lab for you on the fly. Really fantastic. So we love that tool, but we want people to engage with it. So one of the groups that I wanted to highlight here is the environmental DNA group. So this is a big activity in Australia at the moment to screen for DNA in the oceans, on the land, understand our biosecurity risks, our ecology risks, our threatened species risks. And this group's super keen. So they're building a lab at the moment, and they're doing amazing work, like the fact that 2 weeks ago, we couldn't do a lowercase letter in our title. So that was the Edna lab, and now is thankfully the eDNA lab. And we're using that not only to engage with communities, but to engage with partners, aka money. So AGRF, the Australian Genome Research Facility, is self-claimed, and I do believe it, the largest non-for-profit genomics provider in Australia. So if you get sequencing done in Australia, there's a good chance you've got it done at AGRF. For years now, we've wanted to work closely with them. We're currently building an AGRF lab, and we're leveraging the file sources and remote customizable repositories in Galaxy using WebDAV to build a direct data connection. So users can get their sequencing data at AGRF, move it directly to Galaxy, and the link at the end of that, which I might just go to now and then come back, is allowing them to put that data back on their home servers. So the video that's playing here is actually showing a data ingest from the Bioplatforms Australia data portal. What's on the left is our new access that allows a shared API token between Galaxy and the data portal brokered through Auth0, allowing us to directly move files from those private repositories on S3 buckets using CCAN interface to get data into Galaxy. We're really happy with that. It's not fundamentally different, and it leverages a huge amount of existing Galaxy code, but it's very pivotal for our users in Australia who get their data deposited into that data repository automatically by the government. We want them to be able to move that into Galaxy and give them that end-to-end analysis. So I'll go back a slide. This for us is very new. So the funding bodies in Australia changed recently their definition of research to broaden it out of academia into industry and government. And they made that as a statement. It's obvious that industry does R&D. It's obvious that government departments very rarely do something innovative, but it's a statement. And so we've run with that statement. We've actually changed our core statement for the Biocommons to be providing digital infrastructure for academia, government, and industry. And what's really awesome about that is with the 2 months of that decision, these are 2 new projects that have arrived at Galaxy. They both happen to be the New South Wales government. That's fine. 5 years, $10 million to build a biosecurity tracker akin to the Oz tracker for antimicrobial resistance, but for biosecurity, and a restoration project, best understanding of seed diversity so that you can plant and manage your vegetation across the essentially large landscape Australia is. So these are very exciting for us because this is a whole new market that I guess we haven't really tapped, and they give us challenges. The government people have different concepts about sensitivity, data retention, and privacy that is challenging, but challenging in a good way. And because we've got a lot of slides, this is the last one. This was given to me by Nguyen. I think Nguyen does not talk up his own achievements anywhere near as much as he should. And so well done, Nguyen, for starters. He finally got the TPV paper published formally in peer review. So well done to everyone on that paper. And including improvements to TPV are always on our mind. We've heard TPV mentioned a lot already this week. And this is his thinking right now is where to take it from the iterative manual process of slowly increasing and tuning tool resourcing to, not surprisingly, how can we leverage models of LMM, AI to make it more predictive and get it right out of the box. Thank you.
Okay, welcome. Next we'll hear from France.
Merci, bonjour. Okay, so just an update on the French server. So, well, the news about the French server is currently we're working a lot on the backend upgrades, which are not necessarily very visible, but we are changing storage, rebuilding VMs, adding new compute nodes, and this is all done by the team on the right here that I would really like to thank a lot. We're also slowly preparing an LLM server to try to add all these AI features that were presented this week. So hopefully it should be online soon. And well, we use Galaxy for a few different flagship projects like Abromix for antibio resistance and Atlasy for sequencing of biodiversity of genomes from marine species. So, well, in these projects, we use Galaxy as a verification environment. So it drives really the developments of pipelines in this project to do it in Galaxy in a fair way. So really it's important for this project. And we also use Galaxy as a data analysis platform for this the analysis of this data of this project. So we have Abromix, Atlasy, workflow for metabolomics, and that's all. And it's a growing server, which means we have more users. We have the numbers on the right that are already told on Monday. We have ng phylogeny .fr that should be connected very soon to use galaxy.fr. We have Galaxy Bioprod that will be represented as new labs on use galaxy.fr. We have the Fairmont du Futur projects, which we're collaborating with. And of course, we have the ESG for Stars project that will drive the developments and the work on our server in the coming years, specifically on the environmental impact, so with TPV, job cache, and all these kind of things. I mentioned Galaxy Help here because we currently have a separate forum for the French community, but maybe during the COFES we'll look if we can merge it to the main Galaxy Help forum to have a single place for all the community in the world. That's it. And maybe the big thing we are going to work on in the coming year is the federated data analysis, because at the beyond use galaxy.fr there is IFB, which is a federated infrastructure with people working in different cities in France, and it makes sense to do the same kind of thing for use galaxy FR, because if we use Pulsar we can have compute resources in various places in France and data storage too. So we would like to move in this direction, and it's a continuation of what was done in Euroscience Gateway and what will be done also in ESG for Stars. So it's completely natural to do it. And we have a few use cases to do it with facilities producing sequencing or imaging data in large quantity in different cities in France. So if we can connect this data produced regionally with local capacity of computing, it would be much better than moving the data to Paris every time we need to analyze them. And that's it, I think, for France. Yeah.
Okay, next up is UK.
Yeah, hi everyone. Hopefully you already heard about Biofair in these last couple of days, but I'll give you just a quick look at what's coming. So all the others have something to show up for, but not yet here. So there's a quick introduction to what Biofair is. So it's a 5-year project funded by the UK government through UKRI, the national funders in UK, to build a national federated digital research infrastructure. I'll tell you a bit more what that means. The goal here is to have an end-to-end solution for fair research data management and analysis, and also have a platform to run things, but also support and training for the UK life science researchers. So there's 5 major objectives for Biofair. The most important one is probably cultural change to help people adopt fair principles in their research, but there's also defragmentation, as to try to put together projects that are working in silos currently, democratize access to resources like Anton mentioned earlier, and that's also a goal for Biofair. Improving people skills, so training and other related initiatives to improve the skills of people, and in general is data reuse, so helping make more use of the data that's already been produced or will be produced in an efficient way. So what's the structure model for Biofair? So it looks like a complicated picture, but in synthesis, so there is the Biosphere Hub in the middle, which is based at the Erlang Institute, where I'm from as well. But there are other parts that are becoming, just being launched over the next months, and some have been already. So the first probably things that's been launched is the Biosphere Fellowship. So Marisa and I are both Biosphere Fellowship for a few more months now. And the first cohort was all around workflows. So all workflow experts were on the first cohort. And next one's going to be a different theme, but at least this is a good place to start for Galaxy, having workflow expert funded for that in the UK. And the second thing that started is the Pathfinder project. So we have Kevin here that presented a poster around one of the Pathfinder projects. There's, I think, 10 or 9 or something like that projects that have been launched all around fair data for the UK. And there's then the kind of the more important projects, if you want, are the one in the pink colors or the commons. There's going to be 3 main commons and a few additional services like the portal to access these services. So the 3 commons are people, data, and methods. So the people basically starts from the fellowship, but will expand it to a pool of experts that can help in the goals for Biosphere. The data is basically helping people manage their data in a fair way, and the methods is to analyze them. So what we actually doing for the project that I'm just showing in the next slide. So what is the methods common part? So it's currently been awarded to a partnership that includes the Erlang Institute, where I'm from again, Sekera, the company that basically help in Nextflow, that develops Nextflow, and the University of Manchester, which is the lead of the project. And they are the developers of Workflow Hub, you may have heard of. It's a registry for workflows, and a few standards and interoperability tools like ArrowCrate and bioschemas. So how does it look? It's basically this. There's a few pieces, I'll show you everything. It's based on cloud. So we are hosting all of our services on AWS, or we will. And there is a UK Galaxy instance, the first national instance for Galaxy and for biologists. There's a lot of smaller ones, local ones. So this is going to be a kind of unification pathway. And there's going to be a Nextflow instance, like the one that the Australia Biocommons also have. And the Australia Biocommons has been very helpful to Biosphere and to us, to all of us, in basically being the blueprint for Biosphere in a sense. And then the Galaxy and Nextflow instance will be even more connected, and they already are to Workflow Hub. But we also set up a proto data commons, so we call the Share Methods Common project space. It's basically a place for people to put their data that they analyze on the Galaxy and Nextflow instances. But we also support other workflow environments like SnakeMake, Common Workflow Language, and Jupyter Notebooks. We are starting with 9 exemplar use cases, and these are been assembled to cover a few different communities in the UK that are, we think, ready to move to the next level of fairness. So bioimaging and single cell, what else? And genomics for bacteria and viruses. These are some of the use cases. And these are in connection with various research groups and institutes all around the UK. We are also including Pathfinder projects and fellows that have already started, and hopefully we'll also extend to the new one when they are recruited. And that's basically where we are going to start for the first year. So we are all co-designing the system with the exemplar use cases, and after the first year, when we have our first product to show, then we will try to extend it to the other users around the UK. So that's more or less it. If I want more information, please get in touch with me, and I'm gonna have 2 openings soon for Galaxy-related positions. So please get in touch when they come out, or we share them in the usual channels. Thank you.
Okay, next up, South Africa.
So yeah, so I was in that photo that you showed earlier. So I've been working on Galaxy for more than a decade, and now I've actually got money to work on Galaxy, which is yeah. And what I'm working on, you saw on the poster yesterday, is how we can bring accreditable workflows and kind of QMS processes for bioinformatics to lower and middle income country public health labs. Okay. Our part that I'm doing with Bookler, that you've also seen around here at this conference, is making the workflow on Galaxy and doing the accreditable workflows on Galaxy. I should have put a Wellcome Trust logo here. They're funding us. And we will have pilot sites in South Africa, not actually at SANBI, at our National Institute for Communicable Diseases, that's our National Public Health Lab, and then at the EPHI, the Ethiopian Public Health Institute, who unfortunately were not able to be here. They were on the program yesterday. Yeah, so to have Galaxy instances there, work through adoption of Galaxy workflows for Mycobacterium tuberculosis analysis at these two places. Not on this slide because it's not locked in yet, but there is a new game in town called the African Bioinformatics Institute, which I'm a group leader in. It is a network more than a single institute. And yeah, so I'm hoping that by next Galaxy conference, and I'm hoping it won't be another 9 years before I make it to one, we'll be able to talk about ABI involvement in Galaxy. Yeah. And there is not yet a Galaxy Palestine, but if you do want to talk about why you should support scientists in Palestine and how to do so, find me over coffee. Thank you.
Okay, last but not least, by far, is our special friends to the north in Canada. And just to give a little context here, so there's been a long-running instance there for many years now. And there's a very familiar instance, very familiar look to this. And then a few months ago, they approached us. They're very interested in joining the so-called .star network. So there's 111 sort of active instances that we've been tracking around the world. But you notice when you go to like the hub and other places where there's just a few instances that are really called out as being kind of in a special tier, where there's sort of guarantees about the platform being highly available, long running, free for users, this commitment to open source, commitment to community culture, all these sorts of really special components. So there's a formal process for this where you kind of, the instance can come forward and say, yes, we're very interested in joining this .star network. Currently, that's org, EU, France, and Australia. But they filled out the application. There's an executive board that then reviews this. And we're very pleased to say, as of about a month ago, that Canada has joined the .star network. So welcome. So I just want to say congratulations. Also, thank you very much for all your support. Also, what an opportunity to give more to the community now that you're in the .star network. So congratulations. I know you gave a little presentation, but is there anything you'd like to say?
Really unprepared, but yeah, so it's such a great community, and yeah, so we're really pleased to be part of this really nice endeavor that was started a long time ago, and we do think that it's really like a filling a need for the researchers, and so yeah, we are really happy to do it.
Welcome. Okay, so the instances are in a really important way to think about Galaxy and the sort of regional and national and continental activities that are going on. But there's also a ton of work that happens behind the scenes. So I'm going to try and rapid fire just acknowledge some of the key groups that have been involved behind the scenes. So first of all, it's just the enormous user community, the enormous developer community. This is just a snapshot of sort of the main repo on GitHub. We're up to 377 contributors. We're hovering around, hundreds of major commits a week. It's just a really vibrant, sort of active software project. Close to 100,000 commits, since this repo was established. This doesn't even capture the early history. So it's just a tremendously active development environment. Amongst our committers, there's a special group called the committers group. They have the sort of authority to kind of sign off on code changes to make sure they get integrated successfully, following all the best practices. So since the last time we did one of these, we do have one new person. Elizra is here. Maybe he's another. Okay, well, I just wanted to acknowledge him, thank him, and all the committers for the work they do. This is the group that makes sure the code base is stable and bug-free and working and new features. So thanks to the committers here. Another important group has been the sort of roadmap development that's trying to track sort of major activities. I really wanted to have a special shout out to Natalie Kucher, but I also want to have a shout out to all the working group leaders and everyone kind of involved in sort of getting activities integrated. Also, thanks to Gareth for representing Australia, and for all of you working on all your instances around the world. Please, please, please. You can just have, really fine-grained details, or you can have really broad statements like "keep Canada alive." Just really helps us to be aware of like what's going on around the world. And thanks to all your contributions, sir. Amongst our committers, I'd also like to acknowledge Claude Code, who is really emerging as really a valuable contributor and making the process more efficient. I had a really nice chat with John Chilton last night about how it used to be, months of slaving away to get a 5,000 line PR, but now it's in 5 minutes. It just really kind of changes, what some of our ambitions. Of course, we want to, carefully review it. Of course, we want to make sure that it makes sense and is bug-free. But wow, what an enabler where you can go from a thought that you can express in, English or natural language, and then very, very quickly turn that into code. So that's a really important development there. So with that, I'd just like to say thanks to all of you, and thanks to everyone that has been here. I think there's I just really wanted to have a shout out also to the scientific committee organizing GCC. I wanted to thank our hosts. We'll have a little bit more to say at the end here, but thanks to everyone for all your contributions. What a great conference, what a great community. Thanks to all of you.
So one of the things that's happening behind the scene is the user support. So Jen Jackson, where are you? Okay. So I just want you to remember that. And so let's get shout out to Jen, because she's dealing with, well, I want to be polite here, but she's dealing with a lot of things. And we don't notice this because she filters this for us and she helps users. So thank you to user support. So as Berenice pointed out correctly, we made a terrible mistake. Somehow the slides got skipped. Of course, it's very hard to walk this back, and please blame me for this. It's completely my responsibility. So obviously you cannot talk about community update if you are not mentioning GTN and all the training that was happening. So these are some of the slides that got skipped. So I don't know how to, there's really no need for this to express how important GTN and training is for this project in general, because this is the most powerful and again, community supported vehicle of outreach. It's the poster child. So for example, when I write my US grants, despite the fact that the contribution of US into GTN is relatively small these days, of course, I paint this as the best thing ever. So, and it is the best. This is what makes this is what ties this all together. So again, so just please remember the contribution of GTN and also the Galaxy Training Academy, which was happening last year, which was happening this year, which will be happening again. This is a good way to shorten your lifespan organizing these things. It takes a lot of effort. And again, we just need to be really nice to the people who volunteer for doing that. So first, please forgive us. And it was just an unintended mistake, but it's a core part of this project. It will ever be the core part of this project, and we need to try to help keep it funded and maintained. And so thank you.
Our first talk in this session is by John Chilton. He's going to be sharing with us his work on reproducibility in the age of AI agents.
Hi, I just wanted to start off by saying AI is an ethical and environmental disaster, but I'm here because I have to eat. So I'm going to start, as a developer, a question that's important to me is why, when it's easier than ever to write well-designed code, are we instead being inundated with slop? And I think the answer is we haven't figured out incentives. I think this is important for Galaxy because bioinformatics is following suit. We are automating the very reproducibility crisis we've been working on for years. And I think Galaxy must therefore incentivize reproducibility for agents. This is, I think, a bleak picture, but I have an optimistic thesis in this talk, and that is designing for human reproducibility supercharges agents. Yeah, Marius made this point Monday in the UDT talk that these were in development well before agents were involved, right? These were built for humans, and they are currently supercharging agents in the work that, for instance, the Necrotanko lab is doing. In this talk, I'll sort of briefly outline, or it's a sales pitch for 3 work in progress papers I'm writing. None of them about reproducibility explicitly, but they all have this sort of implicit thesis that, yeah, again, designing for human reproducibility is helpful for agents. At Galaxy Live, we saw an example of these notebooks. So here's an example of an analysis with a notebook for antibiotic-resistant analysis. It has a novel topology relative to what's on the GTN and the IWC, and it works using the notebook, and this is outlined in the paper. So we've always had this traditional computational record in the history, but what the notebook brings you is a communication record. What's important in the history, providing it context, what matters, what outputs are relevant. And that's great, and I think that's very important for transparency and accessibility, but for the reproducibility piece, I think what's great is taking that notebook and using it as the basis for extracting a workflow graph. Or just a workflow, I guess that's what I mean. Here's another example in the paper, a differential attack-seek workflow, again with a slightly novel topology relative to what's present in the existing IWC and GTN corpus. And it's demonstrating that you can have images and tables and stuff. The things that we're used to in the Galaxy Markdown is available in these notebooks. And this workflow was extracted from the notebook. So if you've used the Galaxy workflow extraction feature before, you know that it's a little finicky, right? You have to understand jobs, you have to understand collections, you have to understand all of the inputs that are leading to a particular output. It's not been the best interface for what I think is really the premier feature of Galaxy and Galaxy's reproducibility story, and that's taking an ad hoc analysis and turning it into a workflow. With the notebook, you've captured a story, so you've captured reproducibility of not just the analysis, but the communication of analysis. And that's great, that's fantastic. That is a better workflow, but the extraction now is just one click. Take the notebook and extract the workflow from it. This is amazing to me, and I'm really excited about it. And it's a feature that we have designed, it's a feature that I outlined 10 years ago, right? It's been in the issues forever. It's a feature that is meant for users, but it can serve as this gateway between agents and humans also. So we're designed for humans, and it's making agents work even better. You know, sometimes if you've worked with Galaxy and agents before, agents do a lot of silly things. Probably they mirror silly things that sort of a new Galaxy user would do. Maybe collections are hard to understand, and so you use a fixed number of inputs at the beginning, and the workflow you would extract isn't quite as general as it should be, or for perhaps like you know, what the agents will just upload tables it makes up, etc. So we've got this skill reproducibilify, which will take an existing messy history, rebuild it as a clean history with a full working graph that can be extracted in a nice notebook. If you've already run a workflow, Ahmed has this nice skill for creating reports from the workflow sort of after the fact. So that's building workflows ad hoc or using the history. But I think a white whale I've been like trying to hunt for a long time is allowing humans to build workflows outside of Galaxy. I'm going to quickly take a detour and talk about Nextflow really quickly. Because I think the static validation piece is so key, and it is really, I think, a discounted thing that Galaxy does amazingly well. Nextflow has the concept of schemas for workflows, and I put a little red arrow where they apply. You know, it will take the inputs to a workflow and it will validate them. If I did the same red arrows for a Galaxy workflow and what the workflow editor does, these are the arrows you would get. Every tool step is validated, every connection is validated. Our ability to do static validation of the whole workflow graph is stupendous, given that, you know, it's a declarative thing, right? The same holds true for SnakeMake and Whittle. Only something like CWL has this level of validation that Galaxy does. And I think that's amazing. I think the workflow editor is kind of amazing, but I think it's not a tool that bioinformaticians want to use necessarily, or certain classes of them. Certainly many do, and I love that they do, but for people who want to write programs using their existing tooling, we've built this second workflow format that we've been pushing for a long time, that I think now that we have this validation piece in, is great. And we have this toolkit GXWF, which does the conversion between workflow formats, validation of the workflow formats, et cetera. And it does all of those red arrows. It checks all of those things so you can validate a workflow static structure in milliseconds. We have a TypeScript and a Python version of it, 2 runtimes with the same contract, shared specs and testing across them. The TypeScript one can be published or can be run today. We've got CLI and docs listed. It will validate the tool state on workflows, GA, older GA or modern format 2 workflows, validate connections. And all of this, you saw some screenshot there, and I got a couple more of an IDE version, right? So it's great to have CLI tooling, but an IDE is, if you're writing an artifact in a programming language, an IDE is kind of essential these days. And so I just want to thank David for this work, and I've plugged in the GXWF component or library into the IDE. And it's added features such as being able to do find the tools you're looking for in your workflow on the tool shed, find what attributes you can set on the tool, validate an auto completion on the workflow tool state itself. Yeah, and these are things I've wanted for years, and we were finally able to do it. We finally got that static validation piece in the tool state right, and it's very exciting. And again, it's a thing I've wanted to do for years. It's a thing that we've always needed, and it's good for humans, but it's also great for agents, right? I've seen multiple workflows pop up that agents have written, and they just seem to gravitate towards format 2. I don't know if the authors are asking them to, or it just figures it out, but it's more intuitive. It requires less context, and now we've got this great tooling in there. And I think it's going to be, again, designed for humans and great for agents. Probably a controversial thing in this audience, I'm certain it's controversial, is that agents will start writing workflows also. And whether you agree with that or not, I think it's going to happen. And I think that an important part of this process is that the way we do that should be optimized and guided by sort of human expertise and best practices. A common thing you will do to empower agents these days is writing skills. And I think there's many great things about sort of the current skill ecosystem, but it really is a package format, not a source format. It's not really something designed for humans to introspect or edit. And I don't have time to get into all my issues with it, but I created a pattern for creating skills that I think really brings humans to the forefront. And I think it really makes skills that are scrutable. They are understandable by humans and can be managed and maintained by humans much more usefully. So check that out. One of the things that Foundry has, one of the central principles is pipelines. These are journeys to build workflows. Each pipeline is a set of skills. Thanks. So I built the same attack sequence I showed off before, not the same, but I used the same prompt, and I had the Foundry skills build a workflow from first principles without a Galaxy instance, just using the tool shed and the GXWFY, whatever, the toolkit. I've got to come up with a shorthand for it. Yeah, anyway, it made slightly different choices. It had access to all sorts of patterns. So, I mean, I don't know which of these workflows is better. I haven't had time to sit down with the bioinformatician and see if either of them make any sense. But I think these patterns are an example of how the Foundry pattern is great for humans, right? So whether these things just being put in some markdown document by an agent, they're on a website that humans can read. There's a bunch of different kinds of patterns on collections, conditionals, sequence analysis, et cetera. For each collection of patterns, we've got a set of patterns. Each of them has a recipe, and that recipe can be tested and displayed. It's excellent documentation. I talked about how it works in my lightning talk in terms of drafting the workflow. Hopefully this provides some context. Anyway, I think this moment is a kind of a moment of crisis, but reproducibility is more important than ever, and designing reproducibility for humans supercharges agents. So I think that my message here is just that Galaxy must meet this moment by doubling down on our values. Thank you so much.
Multiple times during the conference, the notebook was mentioned, but it was not really presented, and I don't know which version it is in. Would you mind to do like 3 sentences to explain to us what's doing? Thank you.
Oh, okay. So it's just like a page, but it's attached to a history, and it's got that extra history context. They're available in Galaxy 26.0. You can 26.1. You can try them on Galaxy Main today. The notebook extraction stuff I have is an open PR that's polished and ready to be merged, but it probably won't be in until 26.2. You're right. There should have been that, but I had too much to do, and yeah, I'm not really a user-facing person. It would be nice. Why are we laughing? It's true. This is a talk for developers. Yeah, so it would be nice it would be nice if Marius did a talk on the notebooks, right? Or Bjorn or Wolfgang, or people who work with data, and that's not me. But thank you for the question. That was important data I should have included.
Fantastic. Thank you, John.
Thank you.
Okay, so yeah, I'm Danielle, and I'm expecting to be a little short of time, so we're just gonna like jump right in. So I suspect that probably I don't have to sell people here on like how great the Galaxy tool ecosystem is, right? Like there's a seemingly infinite number of those things, and that's really great. And for some people who know what tool to look for, I think that works really well. But I do suspect that there are probably some people who show up and what they have in mind is they know like an organism that they work with, or they have some data set in hand, some question that they want to answer. And for them, the expectation that maybe they have to look for not just one tool, but some collection of tools that they then have to like string together to answer those questions. That might be a bit of a big ask. That might be difficult for them. And so I think this talk is maybe for those people. What I'm going to attempt to introduce here is sort of like a lightweight framework that can sit on top of Galaxy and hopefully facilitate that like data first, use case first type of flow or entry point. So the system is actually in production in 2 different places currently. The first is BRC Analytics, which is very pathogen focused, right? So across like all the different trees of life, viruses, bacteria, eukaryotes, hosts, vectors. If I encourage you to check it out, and if you want something that you don't see there, let me know. I'll add it. And then the other is GenomeArc 2, which focuses on vertebrates and currently is home to like all the VGP phase 1 assemblies. And so like these 2 resources, they kind of reflect pretty significantly different like scientific domains, right? Like the biology of these organisms is very different, and the types of questions that people might want to ask of them can be very different. And the system is flexible to that, right? So even though they share almost no assemblies in common, and only some of the workflows they have in common, with just a sort of minimal configuration of like what organisms are in scope or not, we can handle very different scientific domains. So how does this actually work? Like, what does the system actually look like? I'm going to try to at least high level explain, I guess, sort of the data architecture behind it first. So we have 3 core concepts here. There's the organism, the assembly, and the workflow. And so organisms are always tied to an NCBI taxonomy ID, assemblies to an NCBI either GenBank or RefSeq accession, and workflows are always tied to like a pinned version of some IWC workflow. And then for the case of organisms and workflows, we can also add like some light like manual curation on top of this, so that maybe I'll give an example, will be easiest. So like if we know that a workflow is only really relevant for bacteria for one reason or another, then we can actually annotate that and say, well, this workflow should be associated with the taxonomy ID for bacteria. And that lets us build like a sort of machine readable, like structured context of like the relationships between these different entities that we can then use to build out the interface for the actual application in a like sort of biologically grounded way. Okay, so as an example of that, I've taken 2 different organisms out of BRC Analytics, and the one on the left here is eukaryote fungus, and the one on the right, rather infamous bacterium. And so because of this, they have very different biology and very different types of questions that people might want to ask about them. And so there's listed here examples of different types of analyses that we can support in BRC Analytics today. And I think it's important to note that for some of these analyses, they're in common, right? But it's also important to be able to sort of hide the things that, I don't know if hide's the right word, but basically not show things that aren't relevant to that particular organism and try and like, I guess, like reduce the cognitive burden on users to find the tools that make the most sense for their particular use case. But, right, so we don't like actually show blue and yellow squares to people. So what's the flow through the site actually look like? Like how does this actually work? And there are a number of different ways really that you could navigate through this site. So like I encourage you to go check it out, but I'm gonna just show one really. And we're gonna start here in it's probably, is it fuzzy? Sorry, but we're starting here in the assemblies tab of BRC Analytics, and I'm going to use the fungus from the previous slide, A. fumigatus, as the example to like kind of walk through. So we have we've filtered to our fungus, and we've got a little over 100 assemblies, it looks like, and various metadata about them, so that you can hopefully identify one that's relevant to your need. We're going to use the one with the little green chip there that indicates it's the NCBI designated reference sequence. So if we were to click analyze, we find ourselves being presented with like choices, right? So for, I guess the next most important thing to say is that for each of these assemblies, we also host a bunch of data assets, right? So our partner in this project is the UCSC genome browser, and so we can host essentially like arbitrary annotation there. If you were to click custom analysis here, you'd be enabled to browse through those assets and then take data directly to Galaxy to play with however you like. But we'll click on this select a workflow route first for our example. Okay, so once you've selected the select a workflow route, you have different workflow like categories that are presented to you. So you kind of have to choose like, okay, high level, what kind of question are we answering? I think we picked transcriptomics. Yeah, we picked transcriptomics. And at this point you have like specific workflows then to choose from. And we take like the names and description of things directly from IWC, and you can read through and choose one. And we're gonna use the paired end bulk RNA, yeah, paired end RNA-seq. So I think this is where it starts to get like particularly interesting and valuable. So basically the workflow stepper here that I'm showing, its job is to try and pair together the workflow parameters that we know the workflow requires with data assets that we have available and present simple choices to people. So the first choice you have to make is actually made for you. We know what assembly that you need, so based on prior choices, so we can just sort of hand you the FASTA file and that'll land in Galaxy with you later. So the first real choice you have to make is for the GTF file, like we need gene models, right? And so we have for this particular assembly 3 options, but like different assemblies have different number of options available. So if we pick the NCBI RefSeq option and click continue, we'd end up next having to choose some sequencing data. And there are two routes for this, right? So if you have data like already in Galaxy, you can go through the upload my own data route. But what I'm going to show is if you click the browse sequences button and want to browse like public data. So if we click to browse public data, then we'll find ourselves with a table. And so this is pre-filtered for you based on prior choices and like context. So we already know what organism we're looking at, right? So we can filter based on organism. We can add on the left side panel there filters already for like paired data and RNA-seq, and you can remove those if you like, but you get them for free so that basically you're looking at like some subset of public data that's relevant to your particular need. And then you can also add additional filters on top. So I've added here like just a bio project that seemed to have a reasonable amount of data associated with it. And then presuming you've identified some runs that you're interested in, you land back here with your blue Launch in Galaxy button ready. And then if you click that, you land somewhere hopefully familiar to people here, right? So you have like one last chance really to like look through the workflow configuration and the data assets that BRC Analytics or GenomeR2 handed you. Maybe manage your history or whatever else you need to do to feel confident before you hit the run workflow button. And I think at this point, the thing that is maybe most worth saying is just that, like, as much as we're providing like a sort of guided entry point, underneath like all of the heavy lifting is still done by Galaxy, which means that you still get all like the flexibility and the reproducibility and other general goodness of Galaxy. Sorry, along the way. I think I'm water. Okay, so right, almost done. So we showed also there was like browsing through SRA metadata, but we have a feature that's in development coming soon in collaboration with the Logan folks that we heard from yesterday, actually, that would let you also search by sequence so that you can find SRA accessions that share genomic content with a sequence of interest. Like if you had, say, a gene that was associated with like antimicrobial resistance or something. So look out for that. And then, right, I think so the final point that I want to try and make is that, so the sort of data structure, the catalog that I'm trying to present here, where we have these organisms, the assemblies and the workflows, and we have defined relationships between them. We are currently using it to drive like a human guided analysis, right? But you could equally use that to guide agentic analysis, right? So there's a like partner talk coming from Dan in a little bit, where you'll see like a BRC Analytics analysis assistant. And the core idea is that we can use that structured content to sort of ground an LLM so that hopefully it knows what kinds of suggestions we should make to people and what kinds of organisms and analyses we currently support, and hopefully suggests good things and maybe not the bad ones. So anyway, more on that from Dan later, and I'm pretty sure that's the end. So thanks, I guess.
Danielle, let me ask one quick question here. You showed a really nice example of bridging pathogen data with Galaxy. Is it possible for other people to come in and use different data on top, but still see the same flow of working from a data portal back to Galaxy for analysis in a guided way?
Like outside of pathogens?
Say I had a different data set that I'm looking at. I work in the cancer space. So what if I had a bunch of cancer data that I wanted to analyze in the same way?
So right now, there's no reason it couldn't, right? Like there's no reason it couldn't, but that's sort of like a theoretical yes. The practical yes is some work, right? But yeah, we could get there if there was a driving need. Yeah.
Fantastic. Okay, thank you so much, Danielle. Okay, Danielle mentioned that there's a partner talk, so up next is Dan and Baker.
Okay, so Danielle did a great introduction for what BRC Analytics is. I can, hopefully just build directly on that. But the idea is to go much easier from a research question, an idea, to a running workflow, right? A researcher comes in and just all they know is I want to analyze my malaria data or whatever, and I kind of have an idea of what I want to do. And there are interfaces so you can click through and explore and figure out stuff, but everyone wants to just get a little bit more guidance these days, sometimes from Claude, sometimes from the website you're at. So this talk is about that. But something we've talked a whole lot about already this meeting is being able to trust AI, right? And so with if you can't trust your AI, it's worse than not having it at all, right? So the wrong answer is actually worse than no answer. But because we're building this on the BRC Analytics catalog that does all the validation, we can actually use AI to guide users to validatable analyses, configurations, right? So trust is a design constraint. Every single thing that our BRC Analytics agent assistant does comes from the catalog that's scientifically grounded. It's never guessing. So like Danielle showed, there are roughly 7 decisions you have to make before you can run. So you have to pick an organism, pick an assembly that you actually care about, the type of thing you want to do. From the type of thing you want to do, you can select an assortment of workflows, and then you pick where you want to get your data. Some workflows, you have to define characteristics like ploidy and whatever. Not a scientist. And then, annotations, right? So the worst thing you could do is just put up a chatbot that said, yeah, this is what your analysis shape is, and just make stuff up, right? But with a whole bunch of tools, we can actually very carefully fill in sort of a schema for the thing you want to run. So as a glutton for punishment, and the reason I plugged in, I wanted to try to do this live. So let's see, let's just say we want to analyze our malaria parasite sequencing data, right? So we'll walk through sort of which species, which reference, which color, and then hopefully we end up in Galaxy with it running, right? So switching over to BRC Analytics, I will say this is running locally because right before this, I tried to run on dev and our Claude API key had run out of money. So we need to fix that. But this is running locally with Minimax hosted at TAC, which is free. And it should work. So this is BRC Analytics. This is the regular website. There's the assistant here. I'm going to start a new conversation. And what I'm going to do, the first thing I want to do is, so the assistant can be used not just for building an analysis, but you can also just use it to explore the catalog and ask questions, right? So like, well, the first thing I'm going to do is just say, let's see if this works. Tell me more about what you can do. Okay, so it's only going to tell you the things that it can actually do too. So it's building this list of things from the tools it has available. It's not going to just say, I'll give you scientific guidance on, there's a concern that AI is actually making calls about, what something means scientifically, right? It's never going to try to do that here. It's just going to tell you what we have available and how you can use it. So to start, sorry, I got prompts. I want to analyze my malaria parasite sequencing data. Let's try that. So on the right side, you'll see this analysis setup. There's basically a schema. It's a goal-driven agent that has a schema that it's trying to assist you in filling out, right? It knows the things that you need to provide, and some of these are conditional, some are not, but it knows the things that you need to provide to actually run an analysis on BRC. So it'll talk to you, it'll say, hey, this is what we've got in the catalog. It gives you the list. These are accurate numbers. Vivax isn't in the catalog, great. But I know I want Plasmodium falciparum. So I'm just gonna say, it's Plasmodium falciparum. I'm surprised that worked. So yeah, got it. Plasmodium falciparum. It's got the taxonomy ID, it's filled in our schema on the right side, and it's building our analysis. Now it's going to go ahead and sort of, it's goal driven, right? So it's going to go ahead and say, okay, the next thing I need from you is an assembly. We need to pick one. And I'm just going to say, go ahead and use the reference assembly. So I could have said any of them, but great choice. It's a little sycophantic, but whatever. But you see, we've picked a reference assembly. It's filling in the schema on the right side. And I'll show, well, yeah. I want to look for genetic variants in my samples. So it's going to know what type of analysis. I'm going to try to go a little bit faster here. So now it's going to, these are the two workflows that are relevant for you. And in this case, it does know the first workflow is optimized for your organism. The second one is a little bit more flexible. These are from the descriptions of the workflows. This is something that's built into the catalog. It's information that it's not making stuff up here. So I'm just going to go say, let's go ahead and use the ploidy aware one. So we're filling in the thing, and this is just back and forth. You can also change your mind on stuff. So if I went back and said, never mind, I want to do, genome annotation or something, right? It would unset the bits that it had already set, and it would start over back in the conversation, filling out the things that you needed to do to build an annotation pipeline or annotation run. Okay, so the ploidy aware workflow is compatible. Check the box. So I'll just say, the other thing we can do is since we have this schema, we can provide likely things that you would want to say. So you don't have to say or type it all. You can just click the buttons. So it's paired end, and I'll upload my own files, right? So the data source was the last thing that we needed to figure out to get to a workflow run. So at this point, I'm just going to say continue to set up, and now we're back in this, that Danielle showed off. This is the same exact stepper interface, but now it's pre-populated and configured based on our conversation with the agent. All the details are here in the configuration. You click launch in Galaxy. So you're not seeing the data selector there since we chose to upload our own data, but you'll land in Galaxy. That's another history of mine. And here we are. Now it's the Galaxy workflow. You'd upload your data, or if you already had it in Galaxy, you could just pick it. And that's it. I'm not actually going to run this. So, okay, great. That actually worked, so I can skip all of these. Okay. So the other thing we do is we provide the same catalog over MCP. It's a remote MCP server, so you don't have to install anything. You don't have to have a CLI. An example from Claude, this would also work from, since it's a remote MCP server, you can actually use this just from like the ChatGPT interface. You can add remote MCP servers, but you just say add the MCP server, then you can ask it questions, and it uses the same exact set of tools to search organisms, check compatibility, can tell you about what workflows work for you, what don't, and you can just explore the catalog if you want to. So it's real calls, the agent's not reasoning, it's just answering you. So what just happened? So every scientific decision resolves against the catalog, and there is, so all of the logic is built into the catalog, and the LLM just figures out the user's intent, and through a dialogue, helps you make your selections and go forward. Okay, implementation details. The way we built this is very similar to our stack in Galaxy. It's a fast API, REST API under BRC Analytics, and we also use fast MCP to run all of the. It doesn't power the agents. It runs that's the MCP tools. But what we do is it's similar to Galaxy. It's the same set, like Galaxy's agents use the same set of tools that we expose to the public in the MCP server. We do the same thing here. So there's an agentic stack, it's Pydantic AI, you build an agent, you give it the tools, it's the same set of tools we expose to external consumers. So how do you know it's right? I'll gloss over this because I'm short on time. Danielle talked about how the catalog is validated, and all of the data has sort of a ground truth, right? On the model side, we have a giant set of Pydantic AI-based evals that we run across a range of models for testing, very similar to how we do in Galaxy, right? So I won't belabor the point. Yeah, so three main principles. The language is not scientific decisions. It's not trying to do this at all. It's just trying to facilitate your access to the catalog and get you into Galaxy and help you set up your analysis based on what we know. The determinism is a feature, and every single choice it makes is linked to tool calls that resolve down to data out of the catalog. And doing this, we only have to build the trusted logic once, and we have the MCP server. So other like Orbit or something like that, Scott's used Orbit to access the catalog. It's the same exact set of logic and ground truths. So what's next? Daniel already talked about this a little bit, but we're adding user accounts to Galaxy or to BRC Analytics that are actually Galaxy accounts. So authentication is unified between the two platforms. So you can favorite and save stuff. There's data search is getting extra tooling to, we have a sort of a DuckDB layer over all of SRA's metadata that's quickly searchable and then sub-second responses. And then there's other work that will build on that in the future. And yeah, you can imagine agents doing more of this. Yeah, so that's about it. Hopefully that gave a good demo of how you can actually use BRC Analytics to get stuff done.
Very nice talk. What model is this running on, and how much does it matter for it to be?
So what's real? Yeah, so great question. So right now this is running on Minimax at, it's actually, you know what? I think it'll tell me the exact, oh, I went past it, didn't I? Nope. It's running on Minimax at TAC, and it's not, it's not a frontier model. It's not an expensive model. It's a fast model, and it's free for us. And anyone could, you could deploy it on the Freiburg cluster too, or wherever. And what was the other? Oh, and it works great. So the reason it works great, that was actually mirroring what John was talking about. Agents are really good at dealing with structured data. And ironically, the better an agent is, sometimes the worse it is at dealing with structured data sometimes. But a lot of these, like Minimax is really, really great at tool calling and adhering to schemas. So it's perfect for something like this, where it's a validated catalog that has a strict schema and there's very strongly typed response exchange objects.
What this is, and this whole structure has been really great to see, because like with the FDA, we're facing all this agentic workflows, and then how do you, for regulatory work, and you've got coming from drugs to medical devices or food, how do you verify stuff coming in from companies? Like with this agentic tool like this, how do you verify the source? And I with tools like this and what's demonstrated in general, the Galaxy network could be the way we deal with science going forward, especially if you're doing regulatory validation, right, for companies or countries. So it's more of a statement. I think it's great that this, Galaxy community exists, and it's going to be important in the future. But are you planning upon to, I see this as a beta, or build more of this into the Galaxy interface so that you don't have to go to this tool, let's say?
Yeah, that'd be great. I guess I'd say we're starting small. I have no plans to build this specific thing into Galaxy, but you could imagine using very similar approaches to, guided collection builders or things like that, like things in Galaxy that require either a deep understanding of the configuration of stuff or that just are a ton of clicks and you'd like to talk at it. Yeah, thank you.
So now we have Marius coming to share with us the work on agents.
No, it's a small part of the IWC. I just submitted the talk. So thanks to my co-authors. So I want to talk. It's a bit of an update talk and a bit of a talk about how we want to deal with workflows coming in that are authored through LLM, if we get more workflows, and how we can help with the reviews. And I think like if you're in the programming circles, I think people have shifted a little bit and are very much pointing out that the hard part is not writing the code anymore, which you can agree or disagree. But definitely what's gotten way harder is reviewing. And that also applies to anything that could potentially be generated with an LLM. And so we're seeing the first workflows that are written by LLMs come in. Where's the full screen? Thank you. Okay. Yeah, so first of all, this is the Intergalactic Workflows Commission, IWC. And we love workflows, and everything is centered around Galaxy. We're volunteers. We've created, like, the repository was kind of created in 2018 in Portland, but like most people didn't even know that Planemo can run workflows at the time. Of course, it could do it already for 10 years, but nobody knew. And then we were like, okay, that's the centerpiece. Let's actually get it going when everybody was at home during COVID. And the goals are to lower the barrier to workflow use. If you're dealing with users, you probably have some users that are like hesitant to learn about workflows. At least that was my experience when I was working in a lab with people doing actual analysis. To share and reuse production-ready workflows, assist with the workflow development and testing, communicate the requirements back to the development team and prioritize them properly, and to document tips and tricks and to contribute to the training material. The workflows you can find at iwc.galaxyproject.org. It's a great site that Danon and Ahmed have created for us. So thanks very much for that. I think it's also a bit of a technology playground. It has moved through different backends, but actually look very similar between. So yeah. So what do you get if you contribute? You get like a page for every workflow that describes the workflow, and that's taken from the README. You get relevant links to Docstore, to Zenodo. You see the DOI, you see the author. You get now a nice simplified picture of every workflow. So the chip-seq analysis workflow is actually more than 4 steps, but for, you know, when you're browsing through and you're trying to see what workflows do you want to use, this may be a nice way to give you an idea of like the overall flow of the data. And there is also the full rendering of the workflow below it. We got change logs. I think this is something that will eventually also bring into Galaxy. But this is like the only way where you can describe to your users what changed in the workflow in between versions, and that's important. And of course, you can load up both workflows side by side in the editor, but I can imagine that's not so easy to find out what is actually different. There's instructions for running the workflow on the command line for each workflow with that's generated directly from the workflow inputs. It tells you also like what is the type and like is it the file, is it something else, is it an integer, is it a float, and like what is the default value is already all there. So you only need to like fill in a little YAML file and then you can launch it on the command line. You can run also with sample data. So on the right side, there's a little card where you can select the instance to run. There are a couple of instances pre-filled. So it remembers the last one you used. For me, that was use Galaxy BE, but you can use any one that is pre-filled and you can type your own. So if you have a local server or maybe you just on your desktop, you can do that. There's a try with example data button now that is a bit of a misnomer. It actually runs with the test data. So yeah. Yeah, and you can watch it run in Galaxy. Like you've seen all of that. This has greatly improved as well. Yeah. So why would you submit a workflow to the IWC? The reviewing process. So some of you might think that's like unnecessary, but I think when we receive a workflow, especially from a new contributor, it's often that we're asking, can you make this a bit more general, like no hard-coded genomes, no hard-coded databases, because you should be able to take the workflow to a different Galaxy instance. It's discoverable. I mentioned the DOIs, the citations. You got the static page that you can link to. You get the automatic deployment. You get daily workflow tests. However, we need people to look at them because test is one thing. The other thing is that when they break over time, because like the download links go away or something, these need maintenance. We'll be talking about that a bit more. You get automatic updates. That is a super cool feature where we can update the workflow, we can test it, and then with confidence publish a new version. Yeah, and then hopefully bug reports and contributions from users, and benchmarks is like a stretch goal. We have guidelines to contribute. I mentioned the tests, I mentioned the automated updates. So what's new in the last year? Yeah. Sorry. Yeah. Handing over.
Hello, yeah, I'm Lucille. So I started to put my workflows. I remember in European Galaxy Days in 2022, Nadia was here to help me. I went with, I think it was like 8 workflows for mainly epigenetics and transcriptomics. And now I have put more and more workflows. Then the issue is that you need to maintain them. So I have 22 workflows to maintain. There are some easy updates, just thanks to the Planimo auto update, not automatic tool version bump. If there is no major wrapper change, everything went fine. Eventually, you can just edit the test if the number after the comma changed. Then sometimes there are some middle updates, like the wrapper changed too much and you need the manual step. So I need to do a checkout, go to the EI, put my workflow, try to branch back everything, downloads, and then I need to put the release again for the developers. Please, could we store the release inside the Galaxy? And sometimes, let's say at GCCs and European Galaxy Days, I'm a motivated update. I replace a tool because I heard that, I mean, the tool is a bit old or not efficient, or for resource consumption, there is a replacement that would be better. Also because there is a new feature like the README that is incorporated in the workflow. And then it's quite a lot of work, but I'm always happy to have all my workflow here, and I see that they are used, so it's very, I feel like I'm useful for the community.
Hi everyone, I'm Delphine. I've been using IWC in the context of a large project, the vertebral genome project, and it's very useful to me to have all this workflow available in one place under the VGP title, because while I work with the team directly, there's a lot of people outside of this close relationship that want to use it, and they can go there, see if there's been updates, take a look at the change log, see what's changed, if there's new workflow that have been published. We started with 10 workflow, we have 13 now, and building more workflows. So it's great for conference to communicate that just the one place we're going to find all the workflow related to this project. And one thing that changed lately a lot for me in the way I work with the IWC workflow is it has been a great help. It has been much easier to create test data. Now I just need the workflow, an invocation of real data, so the agents know what it looks like, and a Galaxy MCP, and I just tell it, okay, create me mock data that I can test, that mimic real data, so I can check that the whole workflow is actually giving me the result I'm expecting. It makes also the maintenance way easier, because if you have data that looks like real data, you can catch any change in the results with tool updates. And you can also give it constraints, and it's smaller data on a smaller database. And so it's way easier than trying to downsample real data so much that you lose half of the information. Yeah, that was my contribution.
Yeah. So in one little project that I did is, so we have lots of wonderful tools. This is at the moment, in my opinion, the best one. And we have some that are more complicated, have huge reference data, like hundreds of gigabytes, and are difficult to test with small data sets. And we were working on, so currently all tests run on GitHub. GitHub only has really small machines, so we can't run the large tools on them. So we were thinking of running our tests on the real instances. So Planemo can do this, and we use Planemo for all the tests, and this is nearly ready. Only need to think about where to store the API keys. So.
Yeah, I mean, we're also slowly but surely moving to GX Format 2. John did a lot of work in improving GX Format 2, adding additional validation. And the validation really caught a lot of things. There's a bunch of open PRs from John to fix tests, test syntax, remove like a lot of the old stuff around it in the GA workflows so that ultimately our move to GX Format 2 will be a smooth one. And then I want to talk a little bit about what I wrote in my abstract. So we get more workflows and workflows from LLMs or partially authored by LLMs. So something that we use a lot now to help us are the Copilot instructions, which basically just mirror what is already written in the contributing guidelines, so that we can check that automatically. And it will also do things like check if the labels make sense, if you don't have a space at the end of your parameter, because that space at the end of the parameter is like a real problem if you try to run it on the command line and you don't know that there is a space, because the space is not always visible. Right. We have a Claude review command to help speed up the review, and that's for like a more extensive check than what Copilot can do. There's an open question for the maintenance. Who owns and updates a workflow that an agent wrote, and what are like our quality barriers there? Because we've really had the spirit of like, we don't want to gate. We want, as long as they're described and fit to the criteria, we will accept everything, if it's not obviously bad science. We never made that very explicit, but I think now we will have to. Yeah, so tests, we have the checklists, we have the community reviews, and we want to give as much reviewing tools to the reviewers as possible. We had BRC Analytics, I'll skip that. So yeah, I mean, please join us. We meet every second Thursday. I should also say that like, when you have contributed a workflow, you can definitely become a member and then review other people's workflows. That'd be much appreciated. You've probably noticed that I forgot to put the slides in twice. I am forgetful like that. And I am very happy to have an existing number of community members. But if you have contributed already a workflow, like come join us, review other people's workflows. It would be really fun and nice way to collaborate. Thank you.
Thank you. Are there questions for the IWC?
So I like because at the moment, you said that it's running on IWC tests on GitHub. I thought it was running on .org, but either way, it has certain assumptions about how data managers are configured, in my experience. And I like the new approach of telling it where to run the tests, but I'm just wondering, does that not risk making the workflows now not portable, that they are tested on only the one instance?
Yeah, so I mean, I think that's a good point. And it's supposed to be the escape hatch, right? Like, because we don't control if the server is up, we don't control the queue. We don't know if it is going to work, but if it's the only way that you can do runtime tests, yeah. The other thing is the static validation should hopefully help catch a lot of things that right now we have to run in order to find. I think it's
Excellent. Thank you so much.
Thank you.
Excellent. So we are on to our fifth talk of the session. And are your slides in the folder, Sam?
Yeah.
Perfect. Okay, so we have Isam Gerler, who's going to share his fantastic work on the Galaxy History Graph.
Thanks. So my name is Sam, and I'm in the Shuttle Lab at JHU. And today I have the honor to introduce a new Galaxy core feature, which can also be regarded as somewhat the next iteration of the Galaxy history. It's the Galaxy History Graph. And to understand the motivation of this, I want to answer a few questions during this talk. One is, why is it sometimes so difficult to understand the scientific work we performed with Galaxy? Let's say we worked on a project for a couple of days or a couple of weeks. We went through the tools and the processes and then try to have a complete review and understanding of everything what happened. Why is it so challenging? And then will it help us, and how can we benefit from seeing an actual structure of what we did and what becomes possible if we do so? And to jump into this, let's go back to the beginning first. This is the all familiar user interface, and it shows also how we work and interact with Galaxy most frequently. So we first select data sets, we populate our history list, either upload or retrieve data from different sources. And then we commonly go to the left panel, pick a tool or a workflow, configure and parameterize it. In the center panel, click execute, and then a new data set is produced and added to the list, to this linear list. And then we reiterate this process. So more schematically, it looks like this. We, the user, or in the future or today already, also an AI, selects data sets, executes tools, produces data sets, and then these are accumulated in the history list in a linear fashion, with the latest data set being always at the top. And in this cycle, we also review data sets in between these steps or in between workflows. And in the last year, we made some contributions to improving this review step by having a unified data set viewer, which matches your data set often to a visualization or to some representation for easier review, so you can make the correct decision or a decision on what to do next. So you iterate through this process. But this complex process, a cycle, is a multidimensional cycle, and we always project, mostly at least, the result. We downsample it to a one-dimensional list. And therein lies the problem. If we could see the structure or recover the entire structure visually from our linear list at a later stage in a consistent fashion and reproducible fashion, then we could answer questions like, I used this data set, where did this data set come from, what tools were used, how does it branch further downstream, upstream, so we can explore this graph much, much better than just the linear list. For someone really familiar with his work, he might be able to just look at the history and already know in his head how everything is connected. But once shared or some additions are made, this can get difficult really quickly. And the goal of this is also, or the idea here is also, all this information is already in the Galaxy database. So why can't we see it? Why can't we present it and utilize it? And this question is answered when we look at some implementation strategies and why it failed, or where the initial challenges are. So if we want to go from lineage to structure. So the naive approach, of course, would be, I think it would be, of course, intuitively to just pick a data set and then recursively traverse some multiple individual API requests through the database and try to reconstruct this graph somehow. Even that is limited, because for a data set, you would get the creating job ID, you would make an API request to the jobs table, you would get the input data sets, so you could work backwards to the origin, but you wouldn't be able easily to see how it branches. So without several or multiple requests, this can explode quickly. You have a collection is one tool execution, but many jobs potentially. So that's not feasible on a large scale, and particularly not for large histories. So we had to go back and build the infrastructure first. And one key contribution here was by John to add the tool requests concept. And this basically captures the tool execution intent of the user, and it's associated to a history. So we can now easily go to a history and say, give me all the tool requests, and I have an overview on all these intended tool executions of the user. Even they can break down to multiple or thousands of jobs, but I have a quick overview. And based on this, we can construct the graph on the server, provide a clean, dedicated history graph API, which then allows users and AI agents to query the graph, the history graph, even large ones, it's paginated, it can traverse it, so the AI agent or you yourself can basically navigate this the entire analysis structure, downstream and upstream. So this scales well. So this is something we can offer to a broader audience. And what does this mean? So previously, the final result of an analysis might have looked like this. And as I said, for someone familiar with what workflow they run, they probably don't just see this list. They see internally which tools did I execute and how they are structured. But what we can do now is we can turn this into a graph. And this allows us, this can be done with any history. And it doesn't matter, as I said, you run one workflow. Of course, you would have the workflow graph already in the editor or in the invocation graph. But in this case, you can run multiple workflows. You can run individual tools in between and certain and additional operations, and it will still provide you with a graph representation efficiently and quickly. And of course, you can, this is dynamic graph representation, so it will show you the job status, will show you failed jobs. You can click around to explore the parameters. You can, as you can see here, one tool execution results, let's say in 10 jobs. Then you can look at the individual jobs, see why individual jobs failed, explore the outputs, and list all the executions in the history. And you can also provide this to your, we have an initial history agent integrated into this, which summarizes your history based on the graph view, based on this complete understanding of how the different tools and data sets are connected to each other. And how does this fit into the history, I would say, of Galaxy, into the initial steps? So in 2005, Galaxy had already the history. That's key, right? For reproducibility, it records the entire scientific work. In 2007, we already moved to having workflows, so multiple tools capturing a scientific intent. And then in 2024, Ahmed added the invocations graph. So now this allowed you, for a given workflow, you could observe the workflow execution, which was a major step. And now we take it one step further. We reveal the entire structure of the history. So all analysis, all workflows together in one graph. And what becomes possible with this? So the key here is that we wanted one artifact for different consumers. One is, of course, it should help the user himself or herself understand how the results were produced, right? Explore downstream and upstream relationships, how they branch, to trace scientific conclusions quickly. And the same artifact can now be used to communicate results. They can be consumed in the new Galaxy notebooks. They can be used in scientific reporting. And as I said, explored automatically, explored interactively. And but one of the keys is also improved workflow extraction. So we get out of this entire scientific process and work one clean workflow, which we can contribute back. That's the best piece of reproducibility is a workflow. And finally, also the key here is the artificial intelligence component. So currently, if you point Claude at a large history with thousands of data sets, of course, it will produce an understanding. But the understanding will be based on multiple API requests, and it will be limited in the sense that the information is not provided in one clean piece. And here with this, the idea is that the conclusions and the utilizations of agents will dramatically benefit from this because they'll be able to reason about scientific work right away. And with that, I want to thank John, of course, for his tool request contributions and the API help. Marius helped a lot with support, review, and always very gentle comments. And Ahmed helped a lot with the invocation UI components. So thank you very much. And as someone earlier said today, it's good for humans and great for agents. Thank you.
It's really good work, I think. It's really useful for users with large history. So in the example that you show, it's probably not a big history, probably like, I don't know, 7-8 steps. So that's probably easy to even check in the history with a quick rerun.
Yes.
But probably better, maybe a needed option is to even consolidate these steps. Probably with tags, you can take maybe a pre-processing tag that is given to data sets, and then you consolidate into one single like blob. So three pre-processing steps, and then you have different downstream steps into kind of collections of.
You mean like clustering the graph representation?
Yeah, something like this. So you have blobs of, I've done pre-processing with different tools.
I see. Okay, so for that, so the graph is produced without using any AI reasoning, right? So it's just but I think if we want to cluster it meaningful into structures.
Not clustering really. You can probably take data set tags, the tags given with the data sets, and then group them into I don't know.
Okay, I mean, if you have an idea, like, of course, I'd be happy to like add something to make it more like easier to navigate. That's the key, right? So I mean, we can talk about it later. If you have ideas, that definitely some additional representation which simplifies it would be useful. And I did pick a small history for this example just to fit it on the screen. But the key here is that it should work even with thousands of data sets. Of course, you would paginate probably into multiple individual requests, but you would still get like a huge chunk of the graph in one extremely efficient query, and that's the key. So there's no worry about that it doesn't scale. The scalability was really a big chunk of the work here.
Yeah. So probably then grouping is one. Yeah.
Fantastic. Thank you, Sam.
Thank you.
Okay, we are to the final talk of the session, and it's my pleasure to introduce Helen Patton, who's going to be talking about the AOP toolkit.
Thanks. Sorry for my voice. It's the last day of the conference, so it was a rough night. Okay, so the motivation for this tool came really up while the student I'm co-supervising was writing his paper on quantifying an adverse outcome pathway. So these are molecular pathways, well, not only molecular, but pathways that lead to an adverse outcome. In this case, liver fibrosis. And the goal was to quantify it. So how much of a certain event has to happen in order to trigger this actual outcome, right? Like how much alcohol can you drink until you develop liver fibrosis? So while working on this requires a lot of literature review. So basically, even just querying literature databases and so on, led to a database of 1,900 publications that Robin reviewed. And from that, picked out 73 publications that were relevant. And then those were screened and then used to build a Bayesian model to model this adverse outcome pathway. And if you really look at like having to read 1,900 papers to write a single publication, this is a lot of work. So this needs AI or like generally IT assisting and screening. So the bigger picture was really to build a modular Python package for retrieving, processing, and analyzing scientific literature with this toxicology and AOP use case in mind. And basically, the bigger picture is really we want to have a user-defined search term. So the user needs to query the literature, but we also want to capture having user-provided publications because still a lot of work is not open access, especially in toxicology. You have regulatory documents and so on, which are not indexed somewhere. So this was another need. And also working with different levels of text. So working just with abstracts, full text, figures, tables, and so on and so forth. And then applying large language models and generally AI techniques to mine the literature. So the overall workflow starts with a query where there are multiple databases implemented to get literature. This currently includes EuroPMC, PubMed, PMC, and the AOP Wiki. This is still a prototype. And then we can download the literature, or we can actually plug in PDF files and use optical character recognition or text parsing to translate these into text. And then the next step is to identify chemicals which are mentioned inside the publication. So this we can either do using large language models, basically using any OpenAI compatible endpoint. And the tool kind of templates prompts from the text content and the user input, which then asks the LLM. There's also an alternative pipeline using SPACY and more traditional machine learning tools with which we can identify chemicals. And then we want to link the chemicals to the effect, so linking it to the adverse health outcome. So these are user-defined terms with user-defined relationships. So think about it as triplets. We have the chemical, we have the relationship, and then we have the effect. So the query would be something like, does thioacetamide cause liver fibrosis, right? And this can be also done either by the LLMs or actually running also local models from Hugging Face, so using zero-shot classification. And then the last step is tooling to actually normalize and align chemical names, because like chemical naming is a giant mess. People don't really use identifiers well to like reference to certain chemicals, and then we generate some form of a report. So this is the overall workflow of the tool. And of course, we needed to find out how reliable is this technology, right? How good is an LLM? So we actually looked at a published manuscript by authors within our institute. And this was on gap junction intercellular communication using a specific scrape loading dye transfer technique and in a specific cell line. So the review comprised 328 chemicals, which they collected from 96 different publications. And we took the same pool of publications and ran it through this pipeline to then see the results. And overall, we had a 75% match with the expert list and 95% correct prediction of the directions. So is this causative or non-causative, etc. So in this case, it was about inhibition of this communication. So in a little bit more detail, we have here this nice diagram comparing the different predictions. So if something is within both categories for either the LLM or the review, it means that the literature is ambiguous, which can also happen. So in this case, the LLM identified 3 chemicals overall, where no more 7, which were like ambiguous. Overall, we can see that the LLM and the review kind of had a similar number of chemicals. And the overall consensus on 231 chemicals. But actually, the more interesting part is that actually over 200 chemicals couldn't be actually matched. So we were not able to tell, are these the same within the review or the LLM, or are these really completely different ones? So this requires manual review. And this shows that actually there's quite a lot of like different insights also coming from the same pool of literature, but there's also a large shared component. Why, like, I mean, we are of course not the first ones who encounter this issue, and there are many tools out there, but none of them are in Galaxy, and most of them have a not very engineered implementation, let's say it this way. So we basically identified the steps and the things that we want to do, and then implemented the different modules, and really focusing on being able to extend this. So being able to plug in different literature databases, plugging in different mechanisms. So really the core concepts are finding the chemicals, downloading the literature, parsing the PDFs, etc. And we can see that there are also many different sort of implementation details that manage multiple things. So SPACY can be used for normalization, for finding chemicals. The LLM can do almost everything. But then we also have this zero-shot classification, which can be run locally. Because the goal is also to be able to extend this a little bit towards other domains, because the concept is very general purpose. So yeah, as a next step, what we also plan to do is to actually take all of these annotations that we find and being able to automatically resubmit these to the literature providers. So EuroPMC uses these SciLite annotations for named entity recognition. Because once we've done this process, we can also just submit these things back to the publishers and tell them, hey, these are the chemicals which are in there, so that we don't have to repeat this process and don't have to mine all of this literature again, which would take a lot of energy and is overall not necessary. Then also being able to publish those results as nano publications to have like these small statements about the actual effects and so on. And then also working a little bit more with this AOP wiki. So for example, we had this one use case where we wanted to classify the different AOPs according to the organ system. And this is something we were able to do. And then actually also starting with benchmarking the actual named entity recognition, because this is also one of the main bottlenecks in this normalization process. Like, how good are we really in going from a name to a structure? So this is just to sum it up. And I would like to acknowledge all the people involved in this. So this was mainly led by Robin, our PhD student, and the scientific supervision from Lola. Pavel and Eva did the actual review and case study. And then everyone involved in the technical support. So this tool comes with a lot of cool new features. So it uses the credential system. It plugs into the Use Galaxy U Lite LLM interface, which is now also available on Use Galaxy CZ. So if you don't need your own API key, you can use the ones that are built into those Galaxy instances. And this was facilitated by the admins and people around, so especially Martin, Jose, of course, Björn. And I did the conceptualization of the package and how to bring it into Galaxy and developing the tools and so on and so forth. So yeah, if you have any questions, feel free to reach out. And yeah, let's get to lunch. Thanks.
Thank you. Let me ask one quick question. You mentioned that this interfaces nicely with Galaxy's LLM architecture. Have you tried different large language models and see which ones work best for this particular task?
No, we haven't done that yet, but we still want to do that. So actually benchmarking these. So far, we've run with the GPT OSS 120B model, and that works quite well. But we also still want to make a little bit of a comparison. Also, one part is that actually the LLMs themselves aren't fully deterministic. So running this even to the same model multiple times, you get slightly different results. This is something that we haven't studied yet because we've only been able to actually put the tools onto Galaxy for the large scale work yesterday. So, yeah, so we had it running with the credential system, but actually setting up this shared infrastructure was a bit more tricky. So, yeah.
Fantastic. Thank you.
Scientific software. It's around us. It's either come or coming. It's not going away in all likelihood. And so maybe we can't influence the world, but we can influence Galaxy and where Galaxy fits and what it does in that world. So the question is really, how should Galaxy community adopt AI in ways that expand the access and capability while protecting those core values that have sustained in Galaxy for 20 years. So reproducibility, transparency, and accessibility. In all this, again, I think in this era of AI, is like we want to retain that user trust that I think Galaxy has successfully managed. So I'll hand the floor over to you. Basically, what are your opinions on adoption of Galaxy in AI?
Thank you.
So just a reminder. So at any point when you feel something that you feel passionate about or have an opinion on, just please come down, take the chair, and we'll keep the circle moving. So I see a lot of people sat on the ends, hoping that that means that they're ready to come down and talk. So but please, we'll start calling people out if nobody comes down in a few minutes.
So some of you already heard my opinion about it, but because not everybody was here, I would like to repeat it. I would say I'm a bit afraid that if we put an AI agent in Galaxy, it would like a Galaxy support what the AI agent would say. And why I think it's very useful because it's very difficult to find tools, it's very difficult to find a workflow, a GTN material. I'm afraid that the AI could go above what we would like it to do. So, for example, the live demo, it was asked to the AI agent to draw conclusion. And for me, this is typically what I would not like the AI agent within Galaxy to do.
I agree with you on many things. I think especially the tool findability and accessibility is a really strong part where AI can be really helpful. Because this is also one of Galaxy's major critique points within the user community still, that it's like, it's too difficult to find tools. The tools are stupidly named. It's Yeah, I mean, it's difficult to name a tool well. It's actually like quite challenging. So this is also something where AI could actually become really useful. And another part is actually in really kind of this like stock taking and like creating an inventory and restructuring things maybe, like finding duplications in the inventory that Galaxy has in tools, finding overlaps, like really doing a proper systematic analysis of the 30,000 tools or so that are there. And yeah, using that. For the analysis themselves, like I don't think we can really replace human control, like not at this point. It's like I like to compare the AI always with a colleague who will always give you an answer, right? The colleague, like AI never says, I don't know, right? I have no idea. Go figure it out yourself, right? Which is helpful, but it also erodes the trust into whatever the model or the agent might tell you. So yeah.
Yeah, well, I would say I do find the sycophancy of various LLMs irritating and amusing. Alternatively, it goes both ways. Things that I have used on the Galaxy website specifically a lot is the bug AI is fantastic. I mean, it's like most of the time I have no idea what happened, and it usually gives me an answer that, oh yeah, that makes sense. I can probably fix that myself. That's fantastic. The other thing that I've been doing a lot recently is actually not using an AI inside of Galaxy, but using Orbit, which I think we've mentioned, but I don't think there's been a talk about, right? We haven't had a talk about it yet. I don't know if there's going to be one, but that's a newly developed tool that kind of sits outside of Galaxy. You hook up your own AI to it, and it will talk to Galaxy for you, and you know, it'll run things and then report back that things are running and help you develop plans for how to do an analysis, which I think is by giving that little bit of separation, it maybe helps address a little bit of what you're concerned about, because I totally I understand what you're saying about drawing conclusions. I don't generally trust AI to draw conclusions either. But the thing that occurs to me is that whether or not you and I like that, people are definitely going to do that. It's one way or another. And so giving a little bit of separation, I think, not a bad idea. You know, so if we have another, if there's another tool that somebody's using, before I started using Orbit, I was using it on the command line a lot, which again, is a lot of separation between Galaxy and me. And so I feel like maybe using something like Orbit is not such a bad kind of halfway point where, again, people are going to ask it to not just draw conclusions, people are going to ask it to write papers. And I'm not thrilled about that either, but I know it's going to happen.
Yeah, so again, I kind of echo what the previous speakers have said about letting AI kind of make your conclusions for you and make kind of decide what your data means. But again, like it is inevitable that people will try to do that. And I think this is why it is important to have kind of the AI that understands Galaxy, because like, as you say, with the bug solving, that is something that people now just naturally turn to ChatGPT or whatever to ask it for. So I have actually spoken to users who tried to do an analysis in Galaxy before this option was available, went to ChatGPT to find out what their error was, and ChatGPT didn't understand Galaxy, so it was giving them answers based on the fact that it thought they were working in Python, so they couldn't fix it, and they ended up just giving up on Galaxy and trying to work in Python instead because ChatGPT could tell them what to do there. So I think it is inevitable that you do need to have an AI that understands Galaxy and that can give you kind of the context-specific answers that are actually helpful for users.
Yeah, so I wanted to maybe also ask like a question to the audience. Or I want to say one thing. So if you get very powerful tools, there's one thing that is like I think a guiding angle or something that you can apply. It's the scientific method. Like you can verify results. That's super important. And like
do you generally have a feeling that your users understand the scientific method in their experiments? And do they also actually apply this to their computational research? Because, you know, when you have an analysis built up by an external agent that has like a large corpus of like what they can do, and they will get most of it right, but some of it not. Do you trust them today? If, you know, they just get a Galaxy workflow that's supposed to be okay, and they get the results out. And you see, for instance, we had this example of like a mislabeled, it was yours, right? Like there was a mislabeled SRA, right? So that like completely screwed up the results. And you don't need AI to make that same mistake, but just by running the workflow, right? You get no significant result. And so you would ask yourself, okay, like, does the workflow generally work? Would you produce positive data? Would you test your hypothesis? Would you do a positive control? Would you do a negative control? And like Galaxy has enabled this, right? Like if you've written tools for differential expression analysis, you probably know exactly like what kind of thing you have to pay attention to. But if you run a workflow that does that for you, will you still know that? Will you still check that, like, if you did a knockdown of a gene, that the change is going in the right direction? Because I think it's actually a very similar problem, and something people many years ago have already said about Galaxy, that like it enables people to do powerful analysis and powerful things, but they don't understand it. So maybe it's also a question of like, how can we make sure that people approach what they get out of Galaxy, whether it's agent driven or not, how can they approach it in a critical way?
So following on from that, as someone who supervises a lot of students, some of whom are coming from a bioinformatics background, some of whom are trained to be genetic counselors, I know that they're going to want to use these AI tools. They have a very different level of sophistication. They all want to do the work. They all want, they're used to using them. I think there's an opportunity with all the AI tools that are embedded in Galaxy, like as a platform, to make the use of AI much more auditable and transparent to me as a supervisor, because the thing that I want to know as like a supervisor when a student is giving me something is like, first of all, like, do you understand this? Do you know what happened and like how we got here? And I think that's one of the pitfalls of AI, especially for junior people, is that it can definitely allow you to do things that you could not normally do. And I think that that's where all of us get into deep water with those tools, whether it's software development or designing an analysis or whatever. So the ability within Galaxy to be able to say like, okay, well, there's this workflow and this bit was done with the support of like this AI tool and this agent at this time, and having that be sort of like baked into the reporting is potentially super valuable, not just for that sort of supervision aspect, but also when it comes to, you know, compliance for various journals or any sort of other, you know, agreements that about the use of generative AI that need to be satisfied to be in compliance with any one of a number of different kind of use cases. So I think there is like a lot to be said for just saying, bring it all in, because it's going to happen anyways, and then at least you have that visibility and you're not having this problem where people are jumping out to a different terminal and then, you know, coming back in and things like that. So.
Okay, so I don't want to be the trouble effects, the guys that say, okay, is this always useful and efficient to use AI? I don't have the background and maybe but can we put in balance the ecological aspect, the ethical aspect, the societal aspect, when we decide to propose AI agent to users or for research? For research, yeah, there is a lot of good opportunity, but maybe not for just a chat within Galaxy for everything that can do by themselves and learn by themselves using the GTN, the different support, the tools that are already described, etc., etc. Okay, that's my point.
For me, a good use that I could see for the AI in Galaxy is, well, you get your workflow, you get the result, okay, but sometimes you're not sure why you see what you see, right? We do this workflow, we have these default parameters that are working in most cases, and then you're like, when my data are super noisy and I have this workflow with 100 steps, where can I act to do better analysis? And I think it was discussed that we might have the AI just to Galaxy and not connected to the outside world. And I think that's where it would lack for me, because I would ask, where can I improve my analysis? And say, oh, this paper used this parameter for this kind of genome. And for that, it needs to like look at the literature. Well, you have a crab genome that are weird, they need this specific parameter. And I think that would be, because it is hard. They go to the forum, the users, and I ask the question, but you need to, it doesn't necessarily reach the people who have that knowledge on the forums.
I'm trying to stick with the narrative here and not go backwards. And this is a little bit of shameless self-promotion, but the Biocommons ran a national survey, which they released. It's concluded. It's on our YouTube channel, where they asked specifically researchers in Australia, why are you not adopting AI in your research? So I highly recommend looking at the video, because it basically identified things that I think we can solve and some we can't. So the ones we may or may not be able to solve was research infrastructure. Do we have enough GPUs to underpin it? What do they need? But the primary thing that came out was that researchers were desperate for training on how to appropriately use AI models, because they were so worried about hallucinations and false results that they were looking for a structure and a framework to be provided to them so that they could learn how to leverage AI models. So I think with Galaxy, with a wonderful GTN training network, we may actually have an opportunity to guide people through either the basics or the more sophisticated aspect of using AI in research. So that's one point. Another point, super quickly, our user support desk, which is predominantly an individual called Igor, is fantastic at his job, but he's not a walking encyclopedia. He is in the space of microbial genomics, but not in proteomics or chemoinformatics. And I really missed him when he went away for a month, because I had to do his job as well as mine. So I used Gemini to do many things that the Galaxy bug report was doing, but I'd like to think a little bit more efficiently. I tuned it to identify tools that were obviously admin broken or user broken, and I could address questions like reading a 500 long log file out of a protein simulation to clearly see what the error was without having to read through 500. So I was still doing manual checking, but I wasn't, yeah, I guess I was relying on the LLM to do the heavy work and not the curation.
Mine will be brief. Can we add the skills or whatever you developed to the error report? Is that something we could actually do? Yeah. Okay.
I will maybe be a little bit in the same direction than Gilda. Of course, for Galaxy ecology, Galaxy biodiversity, when we are speaking about AI, we are speaking also about the impact, environmental impact of this. But I will not speak about that, because in fact there is much more things that are important for me, and maybe taking two concrete examples. One is that we don't need to go fast. I don't think we need to go fast. I don't think we need to make more in the shortest time period. For example, we came to GCC with my colleagues from Concarneau, and normally it's something by car is done in 7 hours, and we make the choice to take our beautiful electric cars from the lab, and this was a little bit like a nightmare of 14 hours. I double the time, we double the time. But in fact, it was not a nightmare. It was a beautiful moment. Oh, I will maybe cry. Sorry. But it was so amazing to have more hours to discuss, to play cards, to make things, to discuss about things. I deeply think we don't need to go faster. Another thing is, in fact, what we need is we need people, we need communication between people, we need communities, humanity, And if I go towards things who are more concrete and technical, the technical aspect, we need transparency, reproducibility, accessibility. We need trust. And I will give another example with directly linked. It is more related to the work we are doing. Looking at the production of biodiversity indicators, we can think it's better if we can go faster. If there is a pandemic or thing like that, I think we can share the fact that if we can have results faster, we can maybe face big challenge easier. But in fact, it's not the real, I think, it's not the real issue we are facing today. At least for biodiversity indicators globally, we have a big, I don't know how to say that, but we have a big challenge with, I think, more around transparency, reproducibility, trustability. Because now, if you are looking at biodiversity indicators at national levels, at global levels, and things like that, I can unfortunately say to you that as the system is created, we don't have such things. We can't remove the thing. We don't identify errors in the loop. We can't do things who can ameliorate the process and maybe engage more citizens, politicians, or things like that. Because in fact, there is a lack of accessibility, transparency, reproducibility. And if I am saying this, it's particularly because we are working on biodiversity indicator production since 20 years. There is plenty of things, but this is not really reaching the goal to move forward on a global manner to work better or to live in a better world, or things like that. And really, I think we don't need to go faster, but just better with people, engaging people, and having such community and things like that. And just going back to Galaxy, what if I have a positive things on Galaxy, I was really appreciating the fact that, for example, things we were demonstrating all the amazing work was done on the structuration of the tools, on the manner there is amazing tutorials on Galaxy training materials, who are all the information made by people and peer review, who is used now to answer a simple questions and give direct links. And this is for me the fundamental things who are important. Standards, normalization, works between people, and something like Mario said, the scientific method with peer review and people on the loop always to validate and to produce the content we are using. And AI, maybe chat can reuse and things like that. But to finish, just one question, because I think I don't know if there is people here who never use ChatGPT. Is there someone who never used ChatGPT? Okay. Okay. Yeah. Yeah, ChatGPT at least to have a concrete thing. Okay.
I wanted to say first that I agree with all point of view. Like we have to implement AI in Galaxy, obviously, since as you say, people will go to other LLM platform if it's not available. And I also agree that we have to think about the ecological impact and that we don't have to be the fastest users. But we have to leverage, of course, all the documentation, the GTN, and what I would look for in Galaxy AI is more like a real assistant. I take the example of the UDT, if I want to create a new tool that doesn't exist. I would like to be pointed to the GTN to maybe improve my skills on how I would be able to build the tools myself the next time, and to have more like verbose information, just not the okay, the tool is ready and you can run it, but how it was constructed and from where the information was extracted to select this tool or something else. And also information about how I can document my tool.
and workflows if I want to build them workflows to then upload my tools on IWC with the right metadata, the right tags to make my my new tool shareable. So this is my point of view. This is what I'm looking for in AI.
Yeah, no, I'm just going to steal it for a sec. The aircon really is working down here, so come down and swap with us because it's quite pleasant.
I have a somewhat side topic to bring. I wanted to chat a little bit about previous incentives that existed and worked very well with Galaxy. That whenever you encounter issue, you share information about it and ask for help. Someone helps you, and that information is available for everyone to find. And AI is great at finding that information and helping those people. In many cases now, it's easier or possible to find that or not find information, but to solve that issue. But if it's not written anywhere of how to do it, AI will be bad at those things. It won't have information. So it's really important to create some sort of incentives to keep sharing that information that, oh, I encountered this issue. How do we solve it? Going back a little bit to the previous discussion, I think one important area is that it really changed what was hard, or a lot of areas that were hard before to relatively easy ones if you use AI. But that does not make AI is just a tool. It does not make you an expert in those areas. So I think people have to keep in mind that even if it's easy to do some aspects, like I could probably use that BRC analytics to figure out how to fill out some geoscience workflow with information. I have no idea what I'm getting. I have no idea how I'm supposed to interpret the data. And I think we have to keep that in mind with learning. Which parts became easy? Which parts do we need to emphasize so people learn about them? They are critical about what they get. What are the limitations of the tools they use that become much easier to use now, but they use them? What are the limitations of them? Yeah.
Hello. Yeah, like you said, AI is a tool. It's the technology, as many people say, it's neither inherently good nor evil. But I think the controversy with AI stems from the fact that corporations don't regulate themselves. And right now, nothing else is regulating them. And so we're seeing things like OpenAI and Anthropic just installing data centers everywhere. There's one that is trying to get sold right next to my house back in the US, like a couple of minutes from my home. And OpenAI is now helping with military operations and stuff, which is creepy, and surveillance. And there's a lot of problems, but these aren't problems inherent to the technology. It's the lack of regulation. Now, as a Galaxy, of course, that's not our responsibility. We don't have the power to regulate them, but I think we have some power to minimize harm. I like that, many of the talks today on Galaxy AI related stuff mentioned the use of open source models. I think those are nice. They're lighter weight. They have a smaller environmental impact. They're dumb. But also, I don't think we should use AI to replace thinking for us. I don't want a super smart AI to do the thinking for me so I can go out and chop wood. So yeah, for me, I think the limit of AI that I want in the the Galaxy ecosystem is removing tedious things. Like, yeah, I don't think anyone likes typing out XML syntax and stuff like that. But like I need to be able to understand this stuff. So if the AI just does all the thinking for me, like, am I gonna be able to write the paper? Do I then make the AI write the paper for me? That sounds very bad. So I draw the line at, like, it just does tedious things for me. And I think that's what it should be for Galaxy.
So I appreciate I use also AI for some part. But one thing I'm really afraid with that is that we forgot to maintain what we already have and keep the resources up to date, what we already have, and making sure, because the AI uses these resources to help you and go through the things. But if we don't keep these resources human created and just using AI to do that, that will definitely hallucinate at some point. And I'm just afraid that all the resources, human resources we put currently on developing AI for Galaxy is then not used to maintain, to keep good resources, making sure that we have good training, making sure that all the tools are correctly annotated, because we need human to do that. We need human creations, we need that. I'm a bit afraid with all the development that is happening there that we lose that a bit. So I'm also a bit, yeah, it's useful. It can be useful for many tasks, but don't forget that we need still human to do some tasks, and we need to keep the resources and people being paid to do human tasks. But yeah.
Yeah, I completely agree. And I think the best AI that we can provide user would be an AI that we select the source of information they can use, right? They can have access to the GTN, to the tools documentation, to the BioStar forum where Jen is making great job answering questions. And so because these are resources that are developed by the community, but they know how to use it, we're going to get a good quality information from the AI, right? You get what you input. And but that implies, yes, that we are maintaining as well all these resources properly.
Also a bit because although what Gilda said and Ivan is more the ethical and so forth part, because what I saw, what I'm seeing is a bit of a divergence happening, because at one point you have the ESG 4 stars that now is going to try to optimize everything Galaxy and like look at the environmental impact, and the other part you have it all the AI features are being implemented. So it's a bit of an idea being a bit more pragmatic, like what can we do about it? I'm thinking also what you suggested is like maybe we should create something like a should or shouldn't. Like, when is it good to use? When is it a good idea? When is it a bad idea? But not restrict, because if you restrict, people are going to go somewhere else, and we should ride that wave in some, because otherwise people are going to think we're outdated and not going to use us. So maybe that's the first pragmatic suggestion for really the research.
So one thing I didn't see that anyone mentioned is that currently we are documenting everything we know. And we are writing down everything we know for the AIs. And AIs are work rates because they have access to the documentations we are writing or we wrote before. They can answer very well because they are learned on top of, for example, websites like Stack Overflow, other forums, and so on. But if you just see the stats from Stack Overflow since the ChatGPT started, the number of the questions just dropped. No one is asking questions on the Stack Overflow anymore. So that means that after a while, so it's good that currently, as people mentioned here, that you have a problem, you want to ask someone, who is that guy? Is there AI? You ask AI, it would be answer you so fast. But after a while, no one will share those kind of fix with anyone else. So we will have a lack of information that I think after 5 years, 10 years, no new issue will report to everyone else. Everything's are local or everything are in hands of the big companies if they have access to your history and read them and so on. So how we can fix it? This is one of the questions I just wanted to do this table. And if if one of you has answer for it, please come and tell us how we can fix this problem, how we can improve the questions. And one other thing is that almost all of us have experience with working with Galaxy or even other topics and subjects we are working on. How about the new people are joining us? For example, as a new people who wants to contribute in Galaxy or any other projects, how can they get that much experience to start working with AI? Because we can work with AI because we know something. We have a background of working, how to explain the things to AI. But for example, as a new student just graduated from university, which words, they don't know how to use the words to describe their problem and ask AI even. So this is a really important problem, I think.
Thank you. I think that I wanted to say something about the ecological impact, but I also want to come back to your question because I think that that's very interesting. So that on the ecological impact, I wanted to say it is also a tool. So I think Anton or someone in Anton's lab rewrote, I think, Minimap in Rust and was like 10 times faster. Was it an liner? What was it? No, sorry. I mean, it rewrote a variant caller and it's like the slowest part of a pipeline, you make it 10 times faster. That's also a way in which like you spend energy for like a frontier model, which are like much bigger than like what you do with a local model. But you can, like, if only that gets run often enough, it will offset the energy that went into that. And like, you know, if our brain's active is also consuming energy, if GPT OSS 120E responds within half a second, that was not a lot of energy compared to running FastQC, right? So we have this nice display of like how much energy a job uses. And I've been critical of this in the past because I was like, well, you got to do your job. So, you know, if my genome assembly takes the energy equivalent to half a transatlantic flight, by the way, the presentation yesterday, I think generally it's like one passenger. So if you say 1,000 tons is one transatlantic flight, that's not correct. That is for the whole plane. So this would be 300 flights, A side. So yeah, so there's ways with the model to save energy. So it's a question of how do you use it? And then coming back to the problem of knowledge generation and bringing in the next generation of young people that are learning stuff, I think it's a huge problem because, and it's a really hard one because you can now do, no one can do 10 times as much as they could before. So that's crazy. But I would say that I'm like 50%, maybe 100% more efficient. Like maybe I can pull out like double the features I used to be able to do. And this would, sometimes these are things where I'm like, this I could have given to a student or a team of students, but you got to explain everything in detail from the start up. And that's a tedious thing to do. However, those students will learn something, will understand, they will have written something by hand. And I can contribute features now. I know that architecturally it's sound. I've seen other things built like that. I've built other things like that. So I have an idea of what to pay attention to, where could it potentially break. I know what to inspect and scrutinize. And that's something that like I would also do for other people when I'm reviewing the code, when I'm reviewing what juniors provide, and hopefully they learn something from it. And that is much more difficult now. So yeah, it's definitely something to think about because also the LLMs learn on things that are already there.
So they have a lot of backward-facing data, but they're not necessarily creative. They can recombine things. We've seen horrific claims that AI can do whole research, $10,000 in tokens, you get a paper out. That wasn't ever published then in the end. So that was all bullshit, I think. But, you know, these are interesting questions.
Do you think, don't run away yet. Do you think that it would be possible? Because I agree. The training issue, I think, is honestly terrifying. It's the thing I think about a lot. Is I look at you and I look at Dan, and you guys are so, what LLMs are doing for you is amazing. But that's because, yeah, you've already got 20 years of experience. You know what to look for. Sorry. I've got 20 years of experience. But anyway, but I do worry very much about the junior scientists, junior developers. I worry about that a lot. But I do wonder, but the other problem, I mean, is Jen in the room? Jen? I don't know. I worry very much about, I worry very much about the content that she generates helping people, because that is, I think, a great source of what LLMs use to figure out what's going on in Galaxy, is that they read the things that she has written. And so I do wonder if there's some way to get, to kind of, it feels like spying if you don't do it, if you talk about it the right way. But I worry about, is there a way to kind of collect the data, the questions that people are asking and the responses they get?
So I think John gave a brilliant talk with a lot of ideas that, you know, would take a much longer talk than 15 minutes. But one of the things that he built with Foundry is also that it links back to the information where it came from, right? And I think this is a very important part of that you can understand what was the context of the answer. You can give the attribution, right? Because that's like LLMs, reproduce copyright protected text that was never meant for training. It's a huge copyright violation. A lot of organizations are intentionally not allowing writing code with LLMs, right? Because like, I mean, of course, these are the biggest US companies, so copyright's not going to change or be enforced actually. But yeah, attribution is super important, especially if you want to later on update your response, right? Because what was true for Top Hat, right, might not be true for a more modern transcript assembly program. So, yeah. So attribution and like building software that keeps the attribution in place so that you can also update pieces of it as time goes by.
Yeah, I just realized that I had to leave, but I wanted to comment on Marius. That it definitely will be a reduction type of game. It will need to combine all the initiatives that are already brewing. So yeah, that's basically what I want to add.
Yeah. You can also stay. Now, yeah, given this educational aspect of Galaxy, which is a very important one, I think, right? So Galaxy is great for training, for building knowledge about bioinformatic analysis and other scientific disciplines. And that got me thinking about an analogy, like very old days, right? When you joined a Usenet group or something and you asked a question and you were just asking a question, a very general one without any preparation, people would invariably answer you, are we supposed to do your homework, right? And nobody would reply. That is the old style. And there is some reason for that, and that's two things, right? So one thing was the educational aspect, exactly that if you're not prepared before, then you won't learn anything. You're just copying the answer and you're as dumb as you were before. And the second thing is, of course, time. So people would have to invest resources, and that's time in that case, to answer that question. And I think for AI, this is exactly the same thing, right? If you're asking a question without preparation, you're not gaining any insight from the AI answer, even if it's correct. You're just copying without learning. And there's resources involved. It's not time in that case because AI is super fast, but it's this environmental aspect. So the same fundamental principle holds true here. And that means for us, I think that we should design a Galaxy interface that prevents this kind of use and acts more like a welcome assistance for people who have done that prior work. And a general chatbot maybe is not the right thing for that, but you would need to build it into different steps where it can help the already educated user when he needs the help. And I think that's something we should maybe focus on.
Just a quick interruptions. We have fresh water above there. If you want to grab and get some water, I just don't want anyone to faint or anything. There is water above there. Please go and grab something there.
Thanks. I'm really interested in like the ways in which we can look at like how we can interact with like AI as like a system as well, and how like users would be interacting with the tools, and like where you can actually intervene with that. Someone mentioned like the user might be trying it for the first time, is like copying the error log and they're pasting it into an LLM and they're not getting a useful answer. I wonder if that is like a potential place that like Galaxy could intervene. If you provide, that could be like a space if you updated some error logs to include some more context about, oh, this is a Galaxy thing. And even then you could link to, if you have particular policies around how you think that AI should operate in this thing, or like if you want to have it linked to particular principles, you could have a page for humans, you know, that's like how we think that AI is appropriately used if we have feelings as a community about what that is, but also maybe, you know, just inject context in both ethical and pragmatic.
So I would say some words and then leave. So the thing is that, yes, we can add more things, more details to the job report, to the logs and so on. But the problem is that after 5 years, for example, at the time when Dan and Marius or any other people who are really expert in Galaxy, maybe they want to leave the group. The new people has a different mindset because mostly we are using LLMs. And using LLMs, I think, for myself personally, is changing how I'm thinking. I'm changing how much detail I should expose to the others, how much, for example, about the log, as you mentioned. Should I put this detail into log or not? I'm thinking right now. But in 5 years, I would not think about it. I would ask AI to put every information that you think is more useful. So it means that you are changing the way you are thinking. It means you are changing the creativity ways and so on. So this is the other problem. So how we can solve this to make sure that everyone has the same context in their mindset when they are using the AI, you know, and they are not losing their ability to think, to create, to be creative, to generate something and so on. This is really important, I think.
Yeah. So to your questions or concerns, and I think it's a very important concern. Since humans are stopping to provide their knowledge into online places than just talking to the chatbots, there is a need to keep that information and organize it in a way that's useful for AI agents. And of course, that raises lots of concerns in terms of GDPR or can we as Galaxy really do that, and how should we do that legally and so on. But I think it's the only way to actually keep the expertise being to raise it over time. So let's say that an expert on some topic is doing some analysis, interacting with the chat agent, and then figures out, okay, well, this parameter or this thing, this is not how it should be done, and it instructs the chatbot. This is the correct thing. I know this, right? Can we keep that information for another user of Galaxy? How should we do that? I think that's an important concern.
Let me just interject for a second. So we are about an hour in, or 45 minutes in since the start. And you know, the original plan, I guess, was to kind of break down into smaller groups and have discussions, and then come back to this. We obviously don't have time to do the full cycle, but I mean, I love the fact that people are engaging and working on it. But just to take a vote. Do we want to break into smaller working groups or continue doing this for the remaining half hour? So who is in favor of smaller or continuing this?
Okay, so I guess on the topic that was talked about before, like basically using AI as a search engine to just point at GTN, I think that's kind of a waste of water and resources. Like we can probably put in the effort to index GTN material and other things well enough that a regular search engine can point to that material and maybe even have some boilerplate fluff to make it more interactive and make the user feel like they're talking to someone versus just Google. But if the point is just to point to a GTN tutorial, then we're really just wasting water to do something that a search engine can do. Maybe to do it slightly better. And on the other hand, if we're using it to do more complex things, like not just point to something, but putting multiple things together, then I think it echoes the problem of instead of someone going to the forum and asking that, and then someone else answering like, hey, look at these two tutorials, and this is how you put them together, and then have that information public, then we have like 40 or 100 people asking the same question, and then AI burning the tokens just to do that work and constantly do it forever, essentially, if nobody's gonna ask it in the forum. So in a way, it's for this aspect of like just helping people find things. I feel like in neither case, it's actually good to use AI. I mean, it's very cool, and I understand that a lot of funders around the world want to see it, so there's an incentive to do it, and it's also very cool for users. But like realistically, how much is it actually adding to that person who's trying to learn?
So I wanted to talk about the comment that was made earlier about how as AI usage has increased, the amount of questions on Stack Overflow has decreased. So I just looked it up, and apparently there were 200,000 questions per month in like 2017 era, and now there are only 2,000 per month. So that's like a huge difference, which probably has multiple factors, but still. So again, just spitballing some ideas. Like I don't know what the solution is, but would it be possible based on the demo that was made on the first day? Would it be possible, let's say, if a user marks, let's say the user asks within the Galaxy GPT, asks a question, and if it's marked, is there a way to kind of mark for the user to indicate, okay, you solved my problem, and then for the Galaxy GPT to kind of try to decontextualize the question as much as possible, and then offer the user to like upload it to a kind of like forum, which would contain all the decontextualized questions from the Galaxy GPT, and then the user has to approve. If he doesn't approve, it's not uploaded. And I don't know, just an idea. I don't know what the solution is. So.
I would like to follow up on 4 or 5 different good points that were raised by providing an example. Since smartphones became more widespread, we had a very drastic drop in contribution on Wikipedia because you need a keyboard to contribute. On the other hand, you got more people having access to the internet and so on. So you changed the landscape. A lot of times somebody said it's just a tool. A tool is not only a tool. A tool shapes the environment. What we should look for is ways to, we should look for the behaviors that we want to foster, the incentives that we want to put on. So do we want more people to contribute to workflows, to training? Do we want to have a community shaped in what form? And then given those guidelines, we should build the tool according to be we as a community being shaped by the tool.
Brilliant. You're just opening it for me because I had something brewing in my mind from said ago.
And Alex also put the finger on it in terms of the way I use AI personally is more like a glorified search engine with maybe augmenting the context. As someone who knows programming, but who is rediscovering Galaxy, I sometimes like the words for actually describing exactly what I want. So this is where, I discovered Google, where actually the skill became to find the right keyword to get the right result. While actually here you have a little assistant. The way I see AI is basically an assistant saying, okay, I get your question, your sentiment, and actually these are the things you're looking for. And going back to what you're just saying, it shapes the community. And what I'm afraid of also is the point that was made multiple times, the lack of question, how we can break a community and really help individuals solve their own problem, but not really help each other. So one of the strengths of Galaxy and of lots of community is people helping each other and really having this sustainability built in, while AI may actually makes your work maybe easier, but if it's at the cost of actually losing the human connection between people, the thing that makes you want to work, the motivation for me, I started really excited about programming, and I'm shifting more and more away from the science and more into community building or joining communities, which is like really where I find the joy in the work. So that's the thing. And yeah, the thing that was brewing in my head also, I can't remember what made me think of it, but recently the Russo Prize for statistics that got awarded to R and to the R core team, it was largely in recognition of the tens of thousands of volunteer hours just by pure passion that the people put into a software that's used widely, which is what I'm seeing also here in Galaxy. So that it wasn't built by AI. It could have probably be done faster. You could replicate this, feed to AI and say, build me a big project, give me a big piece of software. But where's the joy in that? There wouldn't be sort of a recognition of the effort people have put into that, and this community that makes you want to participate and add to it, rather than just the technical recognition of, oh yeah, we built a new piece of fancy software.
I guess just one note, and kind of going back a few topics, but it's kind of the sentiment that AI is going to happen regardless of what we do, and we should just like go with it. And I want to push back a little bit against that, and that there are like some initiatives, I forgot the name of the company, but I can post it later on the conference Slack, where authors are, for example, going to this company and saying, I don't want my material to be like fed into AI. And this company has some way of like figuring out if certain models have been trained on that and then invoicing the AI companies on behalf of those people if those models were trained on the content without their permission. So I just want to push back against the fact that we can't do anything about it. Like maybe Galaxy alone can't, but if we take Galaxy and Elixir and the entire research community or maybe even like, I don't know, the EU or whatever, and we all say like, oh, we don't want this to happen, there are ways to maybe unsuccessfully, but at least try to push back or mitigate what these companies are doing. So it's not these companies are just like so big that we can't do anything about it. Like, I think there should be a conversation about what is ethical and what we want as researchers, and then trying to figure out if there is a way to do that, if that's what we decide. I'm not saying we should decide that. And I'm being a little negative, but I do use AI a lot in coding, especially. But yeah, and also even specifically to choose which companies, like maybe, I don't know, I don't want Glock to have access to my stuff for free, but maybe, I don't know, one of the AI models that's built by an open source company that is publicly funded, I don't mind. So maybe we can be more selective of which AI models are ingesting our stuff for free. And yeah.
Oh no, I'm about to defend AI a little bit, and I don't like that. So I think it's true that Stack Overflow is seeing less posts. I mean, obviously that's true. That's an objective fact. But I think that, so NS has complained for years that I never document my stuff, right? Many people have said, John, you never document your stuff. It's just in a PR somewhere. And if you look at the work I've done over the last year, last 9 months, it has documentation. So my thought was always, if I put something out there, I don't know if it's going to be useful. The first person that uses it should write the documentation, right? Well, I don't code anymore. Claude does my coding for me. I'm the first person to use it. I need to make sure that documentation is good, right? So I think it is true that we are losing corpuses of knowledge, but like questions are transient, right? Whereas documentation lives with the code. So we do have an opportunity here to generate better documentation. I just kind of wanted to make that point. This is maybe just a point for the core team. I think I've seen a lot of people do it. I think the core team is producing more documentation than ever, but I just, there's pluses and minuses. That's all I wanted to say.
It just reminded me, you're making the same point someone earlier. I don't want AI to do my work so I can do my laundry. I want AI to do my laundry so I can do my work. So it's like, I think, yeah, let it do the boring stuff, the repetitive thing, and get into the documentation. There's tons of places that I know in R that the documentation is very sparse, or it's been like, don't repeat yourself. And it's full of links to other places. And the way it's written, you say, okay, who knows if the original developer is still around to actually improve documentation, and everyone else is too afraid to touch it. So maybe actually like freeing the time to actually have another look at the documentation, saying, can we make it more user-friendly? And yeah, documentation, there's actually also R documents in the same place, things for other developer and for the users. And you're like, oh, actually, that's two kinds of documentation, twice the effort. Maybe there's extra time for that now.
So following up on the user question answering thing. So of that, I mean, someone's probably done an analysis, but of the 20,000 to 2,000 Stack Overflow decrease in questions, how many of those were duplicates? How many of those were actually valuable new questions, right? That people no longer have to ask because they're surfaced much easier. So I don't think there's value in Jen answering the same question 10 times a week, right? But if there is a question that has already been answered, getting that to a user and then handing them up, like, actually, I think we presented this either at a poster last year or maybe it was the year before, but the idea was, so currently the GTM materials are in Galaxy AI, called the Chat GXY back then, but that was the poster title. But the idea was that the help materials would be in there too. And that hasn't landed yet, but they will. And the proposal in the poster was exactly, I'm sorry, I forgot who said it, was exactly what was suggested was, if there is no good answer, you click a button and then you land on the hub page or on the help page with a pre-written issue template that you can just post. It's not automatic, but it helps surface those questions that actually need an answer. And then all of Jen's time or community's time is actually well spent. So it's a nice filter and a sort of a and then once that answer is there, it makes its way back into the corpus of embeddings, and then it's sort of a feedback loop that actually builds a useful and good knowledge base. And I think that is the plan that we'd like to push forward.
So a couple thoughts. First of all, it's very pleasant down here, and I have my eye on the soap, so I think that'll. So please come down. Please come down. That's number one. A couple other kind of points. So I have a fancy car. It has a weird failure mode. When I drive out of my garage, the windshield wiper goes. And it's like amusing and harmless, and it's annoying because it's like misdetecting something. So some AI failures are annoying and harmless. My fancy car will like drive itself and then like randomly stop in the middle of the highway. And like, thank God, I can also immediately grab the wheel and take over. So I think it's incredibly important in the Galaxy context that yes, we can lean into AI, but like our core principles of like having the history there where you can inspect what's going on is incredibly important, right? We need to keep the human in the loop, certainly today, and I predict for the rest of my life, human in the loop while self-driving, while doing, sophisticated scientific analysis that's never been done before. There's something, I don't know, something quite special about how our brains are organized. A couple other points. As an instructor, there are times where I get stuck where it's like, I know the concepts and like can't quite figure out how to, design my tutorial or whatnot so that it'll work. And then like, hey, hey, ChatGPT or whatever, like why isn't the plot showing up the way? It's like, oh, Mike, you just got to click this button. It's like, oh, yes. So I think, that's a really helpful tool for me because I'm constantly late doing things at the last minute and like Jen's amazing and the team's amazing, but sometimes at 2 a.m. I just need like a quick helper, and like that's been incredibly helpful. As an educator, when I'm teaching my students, I kind of expect 100% of the time they're using AI. So like in my classroom, I've gone back to like pen and paper tests, and I've gone back to like orally defending their projects. These are really important skills where AI, like by design, like yes, it can, I don't know, maybe help you design flashcards, but I think part of the societal change that we're going through is like acknowledging when AI plays a role, and then acknowledging there's going to be forever times when that crutch won't be available to us. So I don't like exactly know how to do this at scale. Like, I thought the GTA this year was incredibly successful. We had 2,200 participants, and we issued more certificates than ever. But I think a challenge on us is like, how do we organize educational activities at scale where we can't have the pen and paper test? I don't know how to do that. I'd be really open to ideas about that. And then finally, clearly for software development, this is like amazing, right? I've written more code in the last year than the previous 40 something years. So that's amazing. I'm writing code in language that I don't really know. That's really fun and exciting. And it's just like opened up all kinds of opportunities for me. So, at some level, like AI is coming, it's here, it's only going to get better. Thank God, though, that we have reproducible workflows. Thank God that we have histories that we can expect. Thank God that we have all these visualizations that can help us see when like weird hallucinations are happening. So humans in the loop, but let's acknowledge what it is. And it's kind of fun and amazing and terrifying all at the same time.
Yeah, I mean, you mentioned the brain, and I think it actually does really do something for your brain because when I got the first Max subscription, I'm now close to the second. When I got the first Max subscription, I started doing things in parallel. I noticed that I would pick up things that would have been an issue 10 years ago on the Galaxy Tracker, and it was always something of like, I'll get to that at one point, and now you can do that 5 or 6 of these strands at the same time, and it's amazing. You feel so great. You feel so productive. And then at the end of the day, you wonder why you have a headache because you still got to look at these things, and you can multitask much harder. And it does not at all encourage thinking through the hard problems. So the hard problems keep stacking up, and you keep solving the easy ones. And I think that's in general a problem. There was a sentiment that like, let's automate the tedious stuff, which I think there are 2 kinds of tedious things. There's the tedious but pleasant things, sort of like, you work on a little bug, you fix it, and you're like, okay, it's just a little bit better now. And that's kind of fun. Like if you do this by hand, it's kind of fun. You learn something. It's fun. It doesn't take all your brain. You can do this when you have a hangover, you didn't sleep well, or both. And there's the tedious stuff that is also unpleasant because you have to it points out things you did wrong, or like things like you don't want to do. So what I want to say is that it's good to also have a little bit of idle time and do things that could be done by AI, but keep doing it by hand just to keep the practice, and that you don't compact your day fully to the point that you can't think anymore. And at the end of the day, you can't even speak anymore, because that can definitely happen. Yeah. So a caution towards the brain. It really does something. This brain rot, like developers have described the brain rot sort of thing. Like the longer you're on the max plan, the less you're able to write by hand. And we don't know what that will mean in the long term. Yeah.
Yeah, I'm back because I realized I didn't grab the wine the first time I was down here. I don't think anyone's grabbed anything, actually.
I mean, John forgot.
Yeah, really good points from everyone. I'd also just like to thank Dr. Schatz for doing paper exams. They're really underrated. I'm glad they're making a comeback. I just want to add that, like, I think when we think about integrating AI into Galaxy, it's nice to make it not feel like it's being shoved into your face. Like it should be like, it should feel like optional, like opt-in, like type of thing if you want that. So, being able to like hook up, your agent API to it or whatever, like, I think that's good. I think that's fine. But stuff like, I'll say, like when they were talking about UDTs in a talk and how it's designed to be like both easier for humans and for AI. Like I think that type of thing is good. That like we should never sacrifice the non-AI usability of Galaxy. And I think any way that like both can be improved, I think that's good.
Points that maybe haven't been mentioned is like a lot of people raise like, yeah, AI helps them so much write code and like be more productive and write more code. But also sometimes the best code is the one that you decide not to write and the one that you don't need. And this is again something where AI systems are like not great at it because they will often tend to over ambitiously do things you didn't even want. So this is maybe one thing. And like a second aspect more related to the Galaxy community actually is that I think what is quite specific is that within the Galaxy community, there's really good like connection between developers and users, and people cross domains and people learn how to talk with their specific user community for whom they are developing the tools. And they might make decisions that are like unintuitive from the maybe coding point of view, excuse me, to serve their community needs. And this is something where AI works well if you have a good sample, if there's a good already set of tools, databases from which it can, for example, learn during tool wrapping. It can learn conventions because it looks at existing things. Now, if you're onboarding a new community, and you don't have these conventions to fall back onto, it will never replace the process of communicating with your users, finding out what do they need. And this is a process that still needs to be done manually, ideally in person. And then as soon as we have like this set of things and the community kind of established, then it can kind of run off and do things on its own. And I think this was something which was very interesting in Jeremy's talk in the beginning about the benchmarking. Because the first thing that I thought was like, okay, this is cool, but it primarily tells us that Galaxy has all the tools to cover the community's needs. Because first of all, there's a benchmark for that specific field and domain that we can ask and that we can like run. The second part is there are all Galaxy tools to fulfill these tasks. And this is already shows a field that is very well established, while this is maybe something that doesn't apply to everything. Not in all domains we have benchmarks. Not in all domains we will have all the Galaxy tools to cover everything. This would be actually interesting to see, like, also how we can like use the same model maybe or the same approach to figure out what's actually our coverage of Galaxy across different domains. So, yeah.
Yeah, I mean, maybe one more thing to also take into account as we, keep working on those AI features is also to never lose like perspective of who are the people that are running the Galaxy instance, who are the humans helping out people, how to reach them, because it's a very, we've recently expanded into pathogen genomics, which is like not traditionally something we've done. And a lot of people were like, so how much does it cost? Right? And it's free, it's open source. And it's funded by various governments, grants, and so on. And they're like, no, really, how much does it cost? Like, what's the catch? And I think there it is like
so important that the users also know there's humans behind this, and that you can go talk to them. And that, I mean, if you do manage to save some time with AI, which it's not my experience, like I don't know. The developers of the core team, I have a feeling, are not saving any time by AI, they're just doing more, right? But if you do manage to do that, then I think it will be a great perspective to do more outreach and say, hey, we are the people that are doing this and we have this great thing. And if you have questions, you can come talk to us. I mean, it's not the corporation, it's not, you know, it's not a product. I mean, we never speak about Galaxy as a product because it is not a product, right? And Claude will happily say the product, but it's not the product, right? It's a project. It's not. So, I mean, I think as we expand on AI, we need to find also ways to make it clear that humans are operating this, humans are doing this, humans are writing the tools, because I don't think it's always super clear.
Yeah, please, the floor is yours, Wonder Saskia.
Thank you. That's a tough act to follow. Well, I'm Saskia, and together with Natalie and Delphine, we will present the latest updates from the Galaxy Training Network and the Galaxy Training Academy. So I don't have a lot of time, so it's going to go a little bit fast, but you can talk to me after and tomorrow at the CoFest. So most of you will probably be familiar with the Galaxy Training Network already. So that is everything behind all these tutorials that you see on training.galaxyproject.org. The GTN is now 11 years old, and we have over 500 tutorials across 35 different topics, and contributed by over 500 members of the community, including probably most of the people in this room. So really a community effort. So since the last time I gave this update talk 2 years ago in Brno, that is 125 new tutorials, 69 new tutorial videos, 162 new contributors, and 4 brand new topics. So I just want to shout out these topics. So Daniela already presented some of the cool things you can do with Galaxy in the digital humanities realm, but she also has this GTN topic where you can learn to do these things yourself. So things like text mining, speech recognition, video processing with tools like OpenRefine, Whisper, and Tesseract. So if that's interesting to you, check out the topic and talk to Daniela. We also have a new plant science topic. We have 10 tutorials now covering things like assembly, genome annotation, single cell, but also things like how to do fair data publications with data plant ARCs, RO grades, or use resources such as the Madland Genome Zoo that Deepti also developed. So she leads this topic, so talk to her if this is interesting to you. Community building topics, all these things that Marisa talked about. If you want to do that for your own community, learn how, all the tips and tricks and best practices, how to set up these cool things like Galaxy Labs and the Codex and SIGs. There are tutorials, and Marisa is there to help you. So yeah, GTN is very collaborative. So we do this on GitHub, and everybody is welcome and encouraged to contribute, whether this is fixing a typo or contributing your own tutorial or starting a brand new topic. We also always need reviewers, so there's plenty of ways to contribute here. Of course, everything you do, you will get recognition for. So everybody who contributes gets their own contributor page. This is sort of your GTN CV. This lists all of the contributions you've made. So this is tutorials or events, or maybe you added some FAQs or a news post, everything, and also in all roles. So whether you were the main author or an editor, or you reviewed or tested these tutorials. We tried to give credit to all these things because there's a lot of work that goes into these things, and a lot of invisible work also often. So if you want to start learning how to do these things or have something in mind that you want to work on, join me in the CoFest tomorrow, and I will help you get started. And then just to lead into the next topic, the GTN is very good to use as an educator. So if you're hosting workshops, if you have people to teach about how to do these analyses, you can use the GTN. So if you just want to advertise your event, you can do that. If you also want an event page or a course handbook for your page, you can do that. We have TIAS, Training Infrastructure as a Service. So if you want dedicated resources on one of the big Galaxy servers, You can get that for the duration of your workshop. All the jobs from your participants will go in a dedicated queue to make sure that everything runs fast and smoothly on the day. We have tutorials, of course, for teachers about how to reuse the GTN materials in teaching. And if you're doing online events, you can get a Slack channel in our Slack, GTN Slack space. And all of these things are used in the GTA.
Okay. Hi, I'm Natalie. I'll go over some of the GTA portion of this talk. So the GTA, the Galaxy Training Academy, is basically the Galaxy Training Network in action. So it is an online asynchronous global learning event built directly from GTN tutorials that are organized and made into training tracks. And then they are supported by instructors and community discussion via Slack channels during the event. So we'll go in through it like quite a bit. So again, it's global and it's self-paced. So participants get to choose the tracks based on their interests and their goals. And so we have tried to either include new tracks and continue improving tracks each year that it's gone on. And then the discussion channels provide support throughout the week, and instructors and contributors guide the learners through the material as they go. So it's all based on basically volunteers who are dedicating their time to helping people throughout the week. It is very important for me to mention that it was not originally the Galaxy Training Academy, but instead it's based off of the original GTN Smorgasbord events. These were very, very popular events that started in 2021. And the very first one was a little bit smaller in terms of what it's had. So it's grown since then, but it had Introduction to Galaxy, Next Generation Sequencing, RNA-seq, single cell analysis, proteomics, and then of course the Choose Your Own Adventure, which we like to do on Fridays. The very first event for this one saw over 1,000 participants in the first year alone. So you can see on the map here where those participants were distributed. So that's pretty cool. So the Smorgasbord is now rebranded as the Galaxy Training Academy, but it is the same principle, and we can thank the original GTN people for that. So the GTA continues to grow into a global Galaxy event. I mean, it's getting better each year. For learners, it's often the entry point into Galaxy for many of them. So again, GTN materials are online. They're supported throughout the week. So very good for them. For instructors, it is an opportunity to teach and mentor. So it's good experience for people to join in. And we saw really, really great instructor growth this last year. I'm very, very grateful for every single person that came. We had more passion than I noticed in previous GTA events. So I was very, very grateful for that. And so hopefully it's become a pathway for new contributors to contribute to the GTN. And that being said, this benefits the GTN directly because the tutorials are tested annually now by real learners. So we're getting direct feedback that is then used to improve tutorials and therefore the GTA. So it's all kind of a family system. So here's a little of the numbers from the 3 GTA events that we've had from 2024, 25, and 26. So you can see our first 2024, we had 28,000 registrations. Then we bumped all the way up to 2,800 registrations. And then 3,500 registrations. And then we did drop down to 2,200 registrations this last year. I will point out that this year we were missing a huge portion of our team. We were missing Teresa. And so things were a little bit more heavy-handed for us. And so we were not able to add as many new tracks as we had hoped to for the year. So we like to think it's probably why there wasn't as many new opportunities. But we did have 2 new tracks that were absolutely wonderful, including digital humanities and ecology. So we were very grateful to see those this year. But you can see the country representation is really, really great as well. So you can see our last one here. So compared to when Smorgasbord first started in 2021, you can see it's pretty much the same distribution. We had a big surge in Egypt, which I find very fascinating. I'm interested to see where they're from because last year I actually talked to quite a few participants from Egypt. And so I wonder if it was kind of a word of mouth kind of thing. And we've also spread more throughout Africa as well. So definitely spreading and growing, which is wonderful. I think this is really cool. So this is to show jobs by new users, and you can see a big spike in May 2026, which was when we had the GTA. So you can see that people are coming and they are participating and they are actively learning, which is awesome. That's what we're going for. One thing I wanted to mention that was new this year for the GTA that I hope we get to continue on, this was huge thanks also to Michael Schatz for he did all the interviews and things like that, is we had a Meet the Expert segment this year where we had 5 experts in their field and they pre-recorded videos and I launched them throughout the event. So that was awesome. It was very well received and we're very, very grateful for everybody's time, including Delphine, who you're about to hear from, and Gareth is here as well. And very grateful for their time because our participants really, really enjoyed it and they learned a lot from you guys. And with that, Delphine's going to go over some feedback from this year's GTA.
Thank you. Hi everyone, I'm Delphine, and yeah, we're going to talk a bit about number and learner reactions. So we had a great response for the feedback this year because we made it mandatory to get a certificate. Last year we had 30 answers, I think, to the feedback. But on these 308 responses, overall the satisfaction is pretty high. More than 80% are above 8 out of 10 satisfaction. And the Meet the Expert series has been very popular as well. It's either satisfied or highly satisfied in the survey. But beyond the number, we also have a great response on Slack of the trainees. Notably, one trainee from 2024 said that we helped them publish the paper, and people are very enthusiastic about the material, say it's very clear and that they love the experience of the training. And for us, it's really important, not only because it's always good to teach, but also it's an event that is building the community. We can see from the response that a lot of the participants are junior scientists, postdoc or earlier stages in their career, and they are declare themselves very willing to continue participating to such events and continue working with Galaxy. And I think we're reaching a lot of people with these kind of events. We know that it's a lot of work. It's very time consuming, especially recording the videos. But when we look at the number, we see that they are widely used as a training material. So 1 is never using the video, 10 is using the video every time, and you can see that is the trend is widely over the using the video. So we're learning lesson from the GTA since it's a new event. Every year we're progressing, we are improving the process. And one challenge is to keep the community engaged because it's self-paced, so a lot of people do that after work or do that the week after, and we still want them to communicate with each other and with us on Slack, which led to the creation of the Help the Expert series to try to engage the discussion. A very efficient process is the creation of this learning path, because for a lot of new users, they arrive, they look at assembly, and there's 30 different topics, and they don't really know where to start. And so having this curated path to get an introduction into the field is a precious resource to allow them to explore the rest of the material once they went through the first path. And we also have a lot of feedback in terms of, this tool is not up to date, this data has changed. And so despite spending a lot of time on the material, it's always useful to have them actively used and being here to receive the feedback. Because outside of this event, people go to the training, and if it doesn't work well, they do another training. They don't really always contact us. But overall, it's a very precious resource for both the GTN but the Galaxy community as a whole, we think, because we get these fresh eyes that never used Galaxy before, and we learn a lot about how they approach the tool. They ask questions about things that are not clear, they report issues, and we can see, this point has been asked repeatedly, it's not really clear. And so when it's on the side of the training, with the contributor update the material, but we also putting the feedback to the developers group so they can see if it needs improving the UI or adding some functionality that make it easier for new Galaxy member to approach. And this process of like learning and trying on UIs, I think is very valuable for improving everything basically. So where are we going from here? We still have lesson to learn in project management, trying to manage such a large group of trainers that are volunteers, so they don't always have the time to go to meeting, and especially we're collaborating between the US, Europe, Australia, and other countries, and so meetings are impossible to set. So talking by Slack is complicated. So we want to improve on that regard. We want to add more formal documentation on how to participate and contribute to the event. And we want to make it easier to update and test the material by updating automatically the tool version, and if there's new parameter, adapting and testing the material on all the 4 Galaxy instances that are supported. So because we have US, EU, Australia, France, and it's a lot of testing to do. And so a huge thank you for all the organizer and helper this year. It's amazing every year to see people taking the time to participate. And please contact us if you're interested. There's any level of help. It can be like testing, reviewing, up to organizing a track for your topic of preference. You can come find us at the CoFest to discuss what's possible. Thank you.
So, hi everyone. I'm going to, for the following minutes, to present you a little bit my journey, personal journey around Galaxy that began more than 10 years ago with the launch of Workflow for Metabolomics. So first, a few slides about what is Workflow for Metabolomics, aka W4M, which you will see is kind of a multi-hat structure that is dedicated to metabolomics. So first of all, Workflow for Metabolomics is a collective. In fact, it was created in 2014 through the gathering of different persons from different French laboratories that has a large variety of skills that combined together had a good potential. So the collective has grown over time and getting more and more members in France, but also beyond. But more importantly, getting more and more partners to help us to become what we currently are. So what is Workflow for Metabolomics made for? The idea that I initially brought us together was that we wanted to provide to the laboratories, including ourselves, workflows to perform complete analysis in metabolomics, it being from LCMS, GCMS, or NMR data, which are the 3 mainly used technology in metabolomics. So we wanted to share the solutions each laboratory used and combine them into flexible workflows in one single environment to make it easy for users to perform their analysis. So without big surprise here, we chose Galaxy to support this initiative. So what is W4M currently? Well, it's a community resource. From one part, we have this subdomain on news.galaxy.fr that we maintain, we support. We gave her tools dedicated to metabolomics that are of interest for the community, metabolomics community. Some of them we develop and maintain ourselves. On the other side, we also provide support to the community in different ways. So there is the training component that is quite important for us. So we do provide some materials to the amazing Galaxy Training Network. I don't know if you heard about it. So yeah, we have some and we try to put more and more of them. We also organize some on-site training. We have this yearly Workflow for Experimenter school, international school, where participants can bring their own data for a full week of hands-on on-site, plus an additional half week of webinars, so organized each year. And we also participate regularly to congresses, to workshops, and we also have a forum for users to ask questions about issues they may have encountered run into during their analysis using the W4M supported tools. So now that you have the context plotted, a few slides about the journey, so some feedbacks about this long-lasting journey around Galaxy. So first, as every story, we had a starting point. So in our case, we were different people with different skills. Some of them were beginners like me. Others were with more experience. And even though nobody in the collective has individually all the skills that were needed, the fact that we had this diversity I mentioned made it possible to have everything we needed for a good start. So if I take my personal onboarding, for example, I was there as first a Galaxy user, someone that would use Galaxy to perform analysis for metabolomics, but also as somebody that would develop tools that would be integrated into Galaxy. Speaking of onboarding, there is one thing that is noticeable that I can mention concerning my own experience, is that I learned a lot through kind of a mentoring. When I arrived, I had only few knowledge, initial training about bioinformatics in general. I was a young statistician. I was able to produce scripts to do the job, but I have no real prior knowledge about Galaxy, of course, but also about, common practices in tool development. But hopefully, I was in this multidisciplinarity field with the collective, so there were people that had the skills I was eager to learn. So I just learned from them. And that's something that is not just my case in the collective, it's something that is true for several people. We just learn from each other by examples shown by others that have the skills, by communication, and having a shared work to train and gain in skills. So here we were exploring the Galaxy. So we begin to step by step produce tools, produce support, trainings, exploring the possibilities, trying to have instances at first to make it available for French people and then more widely in the community. That wasn't always easy, but we do manage to do something with that. So one of the main obstacles we may have, there are a few that are linked to the fact that it's a collective and a multidisciplinary field. So I will not go through all the different obstacles. I would just highlight two of them that I think are personally important to me. First is information in general, and the other one is collaboration. So concerning information, at start, when we begin, we were kind of lacking a little bit documentation for people like me that was a little in between with no prior knowledge about tool development, etc. So at start, it was quite difficult to get the right information if I wanted to have information by myself. So that's something that has improved through time, particularly with the GDN, for example, that improved time after time. But that's still something that is key, documentation, to be able to go through. Even with people that are collaborators with skills, you always need documentation. And the other point about collaboration is that we were a gathering of skills, but it's not just gathering people, it's how to manage to make them work together. And when they're from different fields, it's not always easy, and it's not just about vocabulary or things like that. So that was something that has been sometimes obstacle, but that we managed to overcome to create this resource that you are proud of. So why has this been working? We sometimes present it as the W4M alchemy, with a core team that has skills inside, but also resources, different kind of resources. But more importantly, it's about links with users, because even if in the team we have people that are developers and users, but there is really a strong link with users that can bring biological, chemical point of view of what we are doing, and but also use the tool. Because the thing is, we do not just want people to use the tool we produce. We want users to be able to perform analysis they need for their own research. So this link is really important. So it's kind of a field boost, being involved in the metabolomics community to be able to stay relevant. And speaking of community, I will be short on that because it has already been mentioned several times, but also the Galaxy community is really a key resource with a large variety of topics, aspects that we could build on. So this was really a good boost for us. And so why will it continue? Well, I hope it will. But more than hope, we also have cards in hands to believe it will continue. So there are globally 3 main strengths that I can mention. First, we have the support for major structures in France in particular, with the IFB that was already mentioned during the conference, that has always supported us with team members in work of metabolomics. We also have the National Infrastructure for Metabolomics in France, which is called MetaboHub, with also members that are in the core team. And we also have this Learn Society dedicated to metabolomics, French-speaking metabolomics Learn Society, which is called RFMF, with also, again, members that are welcome inside the team to be sure to maintain this link with these infrastructures. We also have the motivated multidisciplinary folks. Of course, we are a collective. We have people that are really, really meaning to share their work, share their knowledge. So this is a key point, but of course, with the whole community, whole ecosystem that supports us. So this is important. And of course, again, the user needs, because if we produce things that are not relevant to user, it's not really the point. We really want to match the field expectations. And with the fair part of the analytics being more and more visible to users, it's even more important to be there and to have these links to help them going there in things where sometimes it's difficult to make them adopt this fair principle. So this is really something important for us. So that's it. The thank you slide. So I put it some logos and photos, but it's not even representative of other people that we should thank because it's such a common work. So it was just for illustration. We globally thank any person that has participated, even very indirectly, because everything is possible because of everybody's contribution. So that's it. Thank you all, and thank you for your attention.
Maybe just one question around what do you think about what works to have strong connection between users, the core team, as you mentioned on your slide? Is it geographically things, or is it thematic things, or a mix? Or
I think that's a mix. In our case, it's all begin with local exchange. So people that were really active in trying to discuss with people locally, but it's really about people that have this skill to communicate and to find the right people. Because even in the core team, it was not just at start we were just this number and stay the same. It was really like talking to other people, identifying people that would be interested, even if they do not themselves think they could integrate it. Like people that we had in our trainings, for example, we have attendees that 2-3 years ago, some of them went to see them and say, okay, now your experience, we see that you use the resources the most. How about joining the adventure? They would never have done that from themselves because they are users, but if you welcome them actively, then it really works.
Hi there, everyone. I'm John Dugan. I work at Oak Ridge National Lab. Some of you may know Greg Watson. I'm sorry he couldn't be here today, but I'll be giving the presentation in his place. Just to give you some background, for those of you who don't know anything about Oak Ridge National Laboratory is the United States of America's largest science and energy laboratory. Generally speaking, we're tasked with filling in or sort of addressing research needs that can't be met really by academia or industry. So, for example, we operate large-scale user facilities on behalf of the DOE, where basically users can apply for time, and then they can come in, do their science, and then go publish their science without having to pay. That's not really something that can be provided by industry because there's not really like a profit motive, and it can't really be provided by academia because there's not really the capacity to build such large-scale facilities and maintain them for decades, generally speaking. Today, I'm going to talk about how we are trying to build a Galaxy user community within Oak Ridge National Lab, talk a little bit about why we're trying to do that and sort of how it's going in a few different domain areas. So the three that we're going to look at today are neutron scattering, fusion science, and then energy resilience. And some of you may have, if you've attended previous GCCs, I believe it's been presented on before. This is my first one, so I don't know exactly what was presented, but we've been doing the neutron scattering work for 3 or 4 years now. But we've, in the past year, identified 2 new areas where we think Galaxy also seems to fit pretty well. So we're a bit of an odd group in one sense because we don't really do bioinformatics. We don't really necessarily share a lot of the tooling that is developed by the overall community, but we see a lot of value in the infrastructure itself, like the core of Galaxy in terms of being reproducible. Is it's an area where we see, and I'll give a couple of examples as we go, our scientists can really struggle with that, especially when they're under time pressure. And so having this available to them is really valuable to us. So to start, neutron scattering. So like I said, this has been in progress for a few years. So just to go over some terminology, we call it NDIP. That's what everybody calls it inside of the lab. If you go talk to a neutron scientist, they'll be like, oh yeah, NDIP. And then some of them will be like, boo. And some of them will be like, nice. And so, but NDIP is the Neutron's Data Interpretation Platform. It's basically just our fork of Galaxy. I say fork because we do fork the code. It has for a long time been very necessary for us to support what we need, but increasingly that is sort of going away as Galaxy is being developed in the upstream, and so we're trying to sort of conform with the upstream as much as possible. And then we also operate NOVA, which I won't read the acronym, but it's basically a framework that we use to build Galaxy-ready interactive tools. I guess actually, let me go back really quickly. One thing that I want to mention is that something that we've kind of identified in common with all of these within ORNL is that interactive tooling and human-in-the-loop tooling, even if people are doing like agentic workflows and things like that, is extremely important for us. And so just want to make that point. But NDIP is, after a few years of being in development, is actually moving into production now. So basically at our neutron scattering facilities, people are beginning to actually use it as a part of their experiments, which is a really good outcome for us. One, because it allows us to justify funding, but it's also good because it means that we can get people into Galaxy and start using Galaxy. And so as they're doing their experiments and as they're analyzing their data, we can get all of the benefits that they would get from Galaxy by doing it there. And the initial adoption was sort of largely driven by the interactive tooling. So we built custom NOVA applications. So this picture you see here is one that we use at our imaging instruments, where while they're collecting data, they can pull this up and very quickly, just in a few seconds, they can see like pretty large scale volume renderings of their data and kind of know like, okay, have we collected enough data for this experiment to then proceed to the next step of it. And then just one really quick story I want to tell about it is about a month ago, we had our first user complaint. So we had a user that was at the facility doing a neutron scattering experiment, and they could not log into the site. And so they reached out, and they were actually pretty nice, but basically just like, hey, you need to fix this immediately because this experiment is only lasting like 15 minutes. And if I can't get on this in the next 5 minutes, I can't use the software. So we're going to have to do it another way. But so that was good because it means that people are actually using it to the point where we're seeing problems, but it's also bad because that means, we need to make sure that it's robust enough that, and I'll say it was nothing to do with Galaxy. It was our internal identity provider had some issues. So, but yeah, and so this year we've kind of run into a few challenges. One is that we've been kind of asked to transition to a Kubernetes-based deployment so that we can scale better in the future on hardware. Right now, we don't really have scaling problems, but as the usage increases, we expect that we will. And that's been, I would say, fairly non-trivial. It's still a work in progress. And then also improving the reliability of like our overall infrastructure and authentication has also been challenging for us. But there's also been some things that have been nice, like opportunities that we've had. So the U.S. Department of Energy has issued Genesis mission to us, which is basically a challenge to figure out how to leverage AI better to increase the productivity of our scientists. So basically increase the speed of scientific discovery. And we just finished literally yesterday upgrading to GCC2026. And I think the combination of those two things together is going to be really good for us. It positions us well to, I think, support the Department of Energy's goals there. And then another thing that's been nice is that we've actually had some of our neutron scattering scientists start doing their own tool development sort of organically, which is really nice because it allows us to stop doing this kind of like proof of concept development of like, hey, we can build these types of tools and you can use them, because we don't really have that larger community of existing tools that we can rely on. And so having them do that is allowing us to spend more time thinking about like what we actually want NDIP to be and like how to integrate better with the upstream galaxy. So switching over to fusion science, this has been new this year. Basically, we're building a new facility at Oak Ridge called the Material Plasma Exposure Experiment, where the idea is that you can take materials that would be theoretically placed into future fusion reactors, and you can place them inside of this facility, and then it will test them and basically stress test them to see if they're suitable to like withstand the pressures of future fusion reactors, so that hopefully we can build practical fusion reactors in the next, I shouldn't give a timeline for that, but and basically where we're at with that though is because we don't have any existing tooling, we are kind of doing the initial like proof of concept tool development to just say like, hey, we can take these tools and we can put them into Galaxy, and then if you use them this way, we can have like reproducibility benefits and things like that. And currently the way they do it is very manual. And so it's highly beneficial to, there's a very clear benefit to using Galaxy there. And so it's been very easy for us to sell to them, but now we're kind of at the stage where we're needing to actually like deliver an initial product and say like, hey, you can do this. And just to give an example, I literally 2 months ago watched 2 scientists. They were trying to run 2 separate codes to get them to converge on a single solution for a model of this facility. And they ran them at different facilities. And they literally were just emailing them the data back and forth. And I did this like 6 or 7 times, and I was CC'd the entire time, and it was very annoying. And I wouldn't really recommend anybody ever do that. And that was what they were doing. And so, there's really like a huge benefit, I think, to them to be able to have a system like this available. Yeah, for them, I guess I didn't really talk about it the last time. We can talk a little bit about the American Science Cloud, but integration into HPC resources is especially important. Their codes, you just fundamentally don't have time to run them on your own laptop. Like if you could wait 6 years for your answers, then it would work. But we at Oak Ridge, we have access to very powerful computers. We have access to Frontier, which is, I think, the 2nd most powerful supercomputer in the world right now. And then we have access to others like Perlmutter, which are very large and very powerful as well. And so the American Science Cloud is basically the Department of Energy's platform for integrating together all of our HPC resources, all of the models, like the AI models that we're building, and try to bring them together in one place. And so we want our Galaxy instances to integrate with that very well so that all of our users will have very easy access to all of the HPC resources they need. And they'll also have access, hopefully through Galaxy 26's new features that I've been learning about this week, access to be able to build agentic workflows and such with the models that we provide. One thing I want to mention about that, I might have to not do the last slide to say this, but feature request for the AI agents in Galaxy, it's very important for us to be able to bring our own models. If we can't bring our own models, we probably practically can't use it within the lab just because of restrictions that we have. And so I don't think that's possible now, but in our fork, I think I've talked with a few people about it. In our fork, we kind of have like a hacky solution for it, but something more stable in the upstream would be really, really beneficial to us. And yeah, the goal of this is to be basically, while the facility is currently under construction, to get all of this infrastructure set up so that on day one of the facility's operations, we're ready to have users go into Galaxy and do their science in I suppose, a fair manner. How much time do I have? I guess I'll start this. I might not finish it, but it's okay. I think maybe the last thing we were doing is energy resilience. We're basically trying to answer questions of, if we imagine the electrical grid in the United States 10 years from now, 20 years from now, 30 years from now, the question you want to answer is, do you have the energy infrastructure, so you have like the necessary generation of energy, and do you have the water that is necessary to sustain that energy infrastructure without causing harm to people? So these are kind of the questions that we're trying to answer here, and I'll kind of skip over most of this, but this was actually, I would say, a fairly unsuccessful effort on our part so far. It's not dead, but it hasn't really gone well. And the real challenge that we ran in here was that fundamentally, unlike the other projects that we work on, we didn't really have time to build those initial proof of concept tools for them. And so they basically just never got built. And so for us, we need to find a way to be better about how we can educate the scientists on why they should be using Galaxy and why they should be, and how they can sort of learn to do it. And so I'm really excited, actually. The first thing I'm going to do when I go back is to turn on the user-defined tools beta feature in our instance, because I think that looks, superficially to me at least, because I haven't really dug into it, but it looks potentially very beneficial in that respect. So I'll stop there. Mostly out of time. I've got some links here if you want to learn more about this. I'm sorry, I kind of know I glossed over a lot of things. I hear American Science Cloud Genesis terms every day, so I might be, if it sounds insane to you, you can talk to me afterwards. I can try to explain it a little better, but you can also just maybe grab these links and learn more about it. Thank you.
Thank you. Want to come up?
Thanks for the talk.
Yeah.
Thanks for the talk. Very interesting. My question is, why you set up two separate Galaxy instances instead of one with the tools that can be seen from different URLs, like we do with the proteomics and such?
Yeah, that it's a bit of a weird. It's more of an internal politics sort of thing. Basically, NDIP is its own thing, and they don't want other people's stuff in there, and so it's a bit ridiculous. But that's kind of that. That's honestly the reason, though. It's just sort of an internal politics thing of they're very cliquey, our scientists, and so they want to be this is ours and not other people's, and so we don't want to we can't. I guess one practical thing is we can't really share the neutron scattering compute resources with others. I mean, that doesn't mean we need separate Galaxy instances, but it's easier for us to just manage everybody's feelings if they're separate. So I can imagine in the long term, ideally we could just have a single one, and maybe it even could be a use Galaxy instance. Because our instances are available to the public. It's just you can't really do anything if you don't you'd need to be a neutron scattering user to use the neutron scattering one, or you'd need to be a fusion user to use the fusion one. So those are kind of our restrictions. But I mean, it could still be. I would think you could still be a use Galaxy instance, because you could anybody can go to it and use it and look at things and at least see what the tools are, even if they can't necessarily run them, or they wouldn't have the data to run them, I suppose. But yeah.
So yeah, we are always trying to attract other fields of science. So very broadly, why Galaxy and not other platforms? And my second, like maybe follow-up questions, like you definitely develop some tools for specifically for your researchers. So are you pushing some upwards to the tool shed?
So I'll answer the second question first. Generally, no, but really we should in a lot of cases, because a lot of the tools, I would say about 90% of the tools that we build are open source. But we kind of have one practical sort of challenge with that is that, like, in theory, anything that I write at the lab is like kind of owned by the lab. And so I have to get explicit permission for it to be open source. And we can do that, but it's just, it can be tedious enough that if there's not really a compelling reason to do it, we usually won't go through the effort. But in reality, we could probably push 90% of our tools upstream, because they are, and I forgot the first question, but I guess it was why Galaxy. I actually wasn't around whenever we did the initial evaluation of like other options, but the short answer was that the emphasis on reproducibility and transparency of like analysis met the needs that we had at the time. Basically, we were, when I say we, I don't mean like my team, but like our facilities that were kind of criticized at like a overall level of like not really having like a software plan that was like, you know, encouraging reproducible research and things like that. And so it was the best tool that we found at the time. And the more that we've used it, and especially as it's been developed over time, it's improved to the point where I think it's, I couldn't imagine switching off of it at this point. I don't know of anything else that would do what we needed to do like that. So
thank you. Thank you, Doug.
So hi, everyone. I'm Leonid from the Biomedical Computer Vision Group at Heidelberg University in Germany. And this talk will be about Galaxy Image Analysis. It is a software suite for analysis of cell microscopy images that we have been developing for 10 years. So generally speaking, image analysis usually consists of multiple steps. Okay, I will try to prepare. So usually there is some pre-processing involved, which is then followed by the actual analysis step. That might be, for example, segmentation or registration. And at the end, there is some quantification or feature extraction step. Now, the goal of Galaxy Image Analysis is to provide all the tools that are necessary to be able to perform all these steps directly with the Galaxy, meaning that people can use the image data, the metadata, run the analysis, and then they will be able to download or directly inspect the results within Galaxy. We make Galaxy Image Analysis publicly available via the European Galaxy server. So the development started in 2016 when we developed the very first tools, and during the years, the tool set received many, many extensions, so that by today we are able to provide 60 tools for image analysis and image processing in general. Those tools are for different image analysis tasks, comprising, for example, image segmentation, which is the task of determining meaningful image regions that correspond to individual objects. There are also tools for image registration, which is the task of transforming images into a common coordinate system. And there are also tools for pre-processing and for other tasks, such as tracking or conversion of image file formats or visualization. Most of the tools that we have in Galaxy Image Analysis are implemented in Python and based on the NumPy, SciPy, or scikit image libraries, but several of the tools are also implemented as more classical Galaxy tool wrappers to meet technical requirements, like, for example, provision of MATLAB runtime environments. So image data is usually represented using arrays, or represented as two-dimensional or three-dimensional or even higher dimensional arrays, depending on the image data, actually. And one of the fundamental challenges that one faces when it comes to image analysis is that one has to determine what each of the individual axes or dimensions actually correspond to. So given one array of three-dimensional image data, one might maybe guess the y and x axis. But what is the third axis that is marked with a question mark? Is this the z axis? Maybe. but it could as well be the time axis or channel axis. This is actually very crucial to determine because different axes need to be processed differently, usually. You can't just take a channel axis and process it like a z-axis and still expect to get meaningful results out of your analysis. In fact, you can't even guess the y and x axis, and the situation becomes even more ambiguous if four-dimensional data is considered. And as if this wasn't sufficient complexity already, some image file formats permit even storing multiple images, like multiple of such arrays in a single file. So to disambiguify those arrays, those axes of the arrays, it is really absolutely crucial to consider the image metadata, which, however, is a complex task itself and can be quite error-prone and also creates a lot of boilerplate code among the tools. So to cope with that, we have developed the Galaxy Image Analysis Auxiliary Library, which abstracts away all that complexity of dealing with images with different axes. So this code snippet here is a small example of a command line tool that is based on the auxiliary library and SciPy for Gaussian filtering. So instead of dealing with all these possible combinations of different axes, we can simply declare what axis layout our tool logic actually requires. And the axes are then reordered according to the requested layout solely by creating views of the original image data so that no copying is taking place in the background, which otherwise might impair the computational efficiency. The tool parameters can be piped in directly from a JSON file that is created by Galaxy according to the templates and declarations in the XML description of the tool. So on the bottom line, our auxiliary library helps us greatly to reduce the boilerplate code, to keep tools in Galaxy Image Analysis maintainable and extendable in that sense, and also equips them transparently with support for various image representations, including 3D data, but also file formats such as TIFF or ZAR. And one efficiency bonus that we get for free here is that ZARs are actually loaded chunk-wise according to the requested axis layout, which is possible thanks to the Dask library. Yeah, now I want to point out some scientific work that has been conducted in the past using Galaxy Image Analysis. The first two examples concern registration of multi-sample or multimodal microscopy image data. And in the case of the multimodal image data, registration was required for combined quantification of histological and mass spectrometry data. So you can see the two images on the left. One of the challenges that one faces in this application is that the two images are of very different resolutions, as you can see. And using tools from Galaxy Image Analysis, one can use the registration and visualization tools to obtain such overlays as displayed in the center of the slide, where one can actually validate visually how good the registration actually worked. The corresponding studies were published in 2019 and 22. Another example concerns identification and quantification of dynamic mitochondrial events. This was also published in a study in 22, but in a different one. So such events, such mitochondrial events, correspond to short intensity bursts in the microscopy images, like shown in this blue line at the bottom left. And in order to quantify these events, one first has to detect the mitochondria in the images and also to perform tracking to actually account for their movement from one frame of the image sequence to another. And last but not least, I want to provide another example which should showcase that today Galaxy Image Analysis can also be used beyond cell microscopy. So in this case, we have used a DICOM image of a size of 512 times 512 pixels with 107 Z slices for the segmentation of anatomical structures. DICOM is a format which is largely popular in medical imaging. And this has been possible now thanks to the support for the 3D images that we have added to Galaxy Image Analysis, thanks to the auxiliary library. We have also added support for DICOM format to Galaxy, and we have also added a tool that converts the DICOM images, the DICOM series, to a TIFF file using the high DICOM library. Yeah, we have also performed a quantitative evaluation of Galaxy image analysis, and for this we have focused on segmentation, which is very crucial image analysis step, and also a prerequisite for many subsequent image analysis tasks, such as feature extraction or quantification. And for this evaluation, we have used two publicly available benchmark data sets of GFP transfected mouse embryonic stem cells. And to quantify segmentation results, we have used performance measures which are well established in the community. So they are region-based and contour-based measures. Upwards errors indicate that higher values are better, and downwards errors indicate that lower values are better. And the best values are highlighted in bold respectively. So we have applied Super DSM from Galaxy Image Analysis. We have also applied 4 other tools, and as you can see, Super DSM actually performed best in this comparison, followed by CellPost-SEM. CellPost did not yield meaningful results in that case. Odds thresholding and airflow also performed quite well on the second data set, which are also included in Galaxy Image Analysis. Interestingly, this evaluation was also performed using a tool that we have available in Galaxy Image Analysis, because it is useful to determine the best suited tool for a specific use case if you have a bunch of tools to compare. Yeah, we have also assessed the memory usage of Galaxy Image Analysis and compared it to a different tool suite. So in that case, we have focused on image filtering as an example, specifically in mean filtering, which is a very standard operation. And it is implemented in Galaxy Image Analysis and also in the ImageJ2 integration, headless ImageJ2 integration in Galaxy. So what we have done is that we have applied both tools to images of different sizes, and we have recorded the peak memory usage. And as you can see, the memory usage by Galaxy Image Analysis is about the half, just about the half of that of ImageJ2. Yeah, so finally, I want to give some numbers on software usage and dissemination. So we had almost 110,000 runs on Galaxy on the European Galaxy server since 2018, with about 20,000 tool runs in 25. We do not know the numbers for other Galaxy servers, but we know that the tools were downloaded about 30,000 times until March this year from the Galaxy toolshed. So yeah, today we are taking a look back on the last 10 years of development of Galaxy Image Analysis. And one of the most critical building blocks, I would say, has actually been adding support for different kinds of image data, like providing support for various data representations like 2D, 3D, multi-channel data, and so on. But also for the various file formats, it becomes more and more important, like TIFF and ZAR and so on. Yeah, Galaxy Image Analysis has been used at least in 3 peer-reviewed cell microscopy studies, and is also applicable to other imaging modalities. We have also demonstrated that it has some superior performance and efficiency compared to other tools and tool suites, and pointed out that there were about 110,000 tool runs since 2018 on the European Galaxy server, with something about 20,000 last year. A special thanks goes out to Dan Wang from the University of Florida for providing us with the mitochondrial image data, and to Björn for his huge help with the Galaxy platform and deployment of tools on the European Galaxy server, as well as all code contributors that we had. Thank you all for your attention. If you have any questions, I'm very happy to answer them.
Thank you for the talk. Sorry, I don't know if this was mentioned. I didn't see a mention. So because you mentioned a lot of tools and workflows, are there plans to submit them to IWC, and IUC, the tools and workflows?
So there have been discussions from time to time, and some of the workflows, not the ones that I've been showing now, but at least one of the workflows that we have developed, we have by now submitted to the IWC, actually a few years ago already. Lately, we've been concerned a lot about modernizing the whole thing. Like I mentioned, implementing this auxiliary library, adding support for 3D data, which is really robust, and so on. And this is kind of, I wouldn't say it's ongoing work, but it's still not that much stable and finished. I would say it's time to maybe put it to IWC or IUC or something. So we have it on our radar. We will see what the future brings.
Thank you. All right. Thank you. I'm Danon Alireza. So this is about rewriting the hub. It's something we've needed to do for a while. And hopefully there will be no demo because hopefully everyone's been using it this week already, right? Maybe if you didn't know it. So here we go. So one thing to keep in mind is that the hub's always been migrating. We wrote the first version of the hub. I couldn't actually find when we stood up the Moin server, but it wasn't a corpus of markdown documents at that point. It was a wiki with a whole bunch of, it's a database. So that's what we had at first, the regular wiki. And then we moved to this Metalsmith sort of minimal version. We had this is markdown files statically generated and presented. Here is the Gridsome era starting in 2020. Here's the refreshed Gridsome era starting in 2023. And here's where we are now with Astro. And that's what we're going to talk about, how we got here and hopefully how we made things a little bit better for, well, we'll get there. Okay, so the focus, writing a new static site is pretty easy. Anyone can do it, especially these days with Claude. The hard part here was it's 4,500 pages, like we said. There's tons of custom, there's tons of stuff that people depend on, like embedded pages. So if you go to usegalaxy.org, the central welcome actually is served out of the hub. So bits of the hub show up in different contexts that you may not necessarily control. So we have to be very careful with what we put on galaxyproject.org. Why do we have to do this now? So like I said, we adopted Gridsome in 2020. It's 2026. The last commit to Gridsome was like 4.5 years ago. We adopted it, and then within a year, it was abandoned. Poor choice. It still uses Vue 2, which is totally end of life. It's done. It has this cool GraphQL layer for aggregating data in different ways, which sounded incredibly promising, but it turned out that it just made it super difficult for people to actually write their own new pages, right? And to actually use. And as it got bigger, it was incredibly slow. I think the build time was something like 15 minutes before we cut over, just to build a static website. So aging framework, we had to do something at this point. Is that better? Okay, that was driving me crazy. Okay, so the scale of the problem, 4,500 different pages, news and events feeds, the platform directory with the listing of all the websites or all the Galaxy servers. There were different regional subsites that we implemented. So, EU had to have a subsite that aggregated just EU relevant stuff. There's anyway, there's a bunch of different ones. 36 of these bare pages, which are the pages that people embed in other contexts that we don't control, that we had to worry about. So the number of pages wasn't necessarily the hard part. It's just the large variety of things that we, didn't actually have a good catalog for, as it turns out, that was the problem. So get ahead of myself. Region-aware content, the iframe pages. There were all kinds of weird legacy parameters controlling different views. And then it turned out to be one of the easiest parts to fix was that we'd had this backlog of Moin syntax that turned into Markdown. Then we had some GitHub flavored Markdown. Then we had other flavors of Markdown. So we had like 3 different flavors of Markdown, Moin syntax, and a pile of patches that made this all render at the end of the day. Because we'd never just sort of fixed it. The other hard part was it's galaxyproject.org. This is what people go to. People are adding new content every single day. So we had to sort of build a new airplane to jump to while we're still flying this one, right? And that was a challenge. So on the migration of content, without Claude, this would not have happened. It really made it so easy we switched to a strict build, and then we allowed it to fail. And then we would have Claude loop and go, okay, why is it failing? That's weird Moin syntax that I no longer understand because you deactivated all the patches. Fix it. You could imagine doing this so when we migrated from Moin to Metalsmith, Dave Clements and I did this with hundreds of little Python scripts that made one type of modification, right? It would look for a specific syntax, adopt it or adapt it to the new syntax and fix it. We obviously didn't get all of it, but it was incredibly painful, and Claude was a savior here. Yeah, now Alireza is going to talk about the rest.
So, okay, hi again, I'm Alireza. So as Danan mentioned, we had many problems with the previous GridStorm hub, and we had to find a strategy to fix this problem while the hub is going and it's growing and it's live, and we don't want to kill anything on the air, and we have to have the behavior preserved. So we use these 3 steps. The first step was we went through a pre-processing pipeline, which was to use the to convert the GridStorm era conventions to the Astro using the Astro engine, and then it means that the Astro is understand the contents from now on. Then we had to get rid of the GraphQL. So then we started to build a new JSON search index, which is now running locally on the browser, and it's filtered locally. It's faster than before, and then we could get rid of the GraphQL. And at the end, when we had everything working, we started a phase cutover. On that time, we had the new version and the old version running side by side. The new version was running on a path. It was astro.galaxyproject.org, and then we asked some users, and mostly Bjorn was helping us to make sure and verify every links, every deep queries are working, all the embedded pages are working from for using the Astro news sites. And the goal, as I said, was firstly to preserve the behavior of the hub, as many servers, many sites are dependent on the hub contents. So the current hub is running on this new stack. As you can see, it's a quick map of the most important part of the new stack. It's modern and small parts. So the Astro engine is responsible to create the static parts of the framework. And then we are using view-free to hydrate the interactive sections of the hub. So one of the things that you might ask is that why we choose Vue is, and the answer is that we are mostly use Vue in the Galaxy ecosystem, and we don't want to bring some new technology to the development experience to Galaxy. So the contents are all in Markdown and MDX, which is some powerful extension of the Markdown. We use the Tailwind to a styling of the components based on the brand tokens, which I'm explaining in the coming slides, and the Rika UI to have accessible components primitives that makes the Galaxy Hub fully accessible to every user. And everything for the hubs are served using the CloudFront. Everything are statics, and they are served in S3 buckets via the CloudFront. So the current anatomy of the pages in Hub is something like this. We have 3 phases. Let's take the use Galaxy directory, which has 224 servers. Each server has a one Markdown content file, which declare the server, and then which has also title, URL, and some more fields. Then Astro at the build time gets all the collections related to each server, aggregate them, and build the JSON index and so on. And at the end, we add the view layer for only the interactive parts. And in Astro, they call it the view islands, which means that it's only activates when you're interacting with those parts, like when you are interacting with the sidebar or search bars and so on. So, and this process is happening exactly the same in every servers. Around 1,700 news we have, and also 1,400 events files we have, and every other Markdown and directories are hosted in the Galaxy Hub. So as we mentioned, we had a really great achievement here. Previously, we had more than 15 minutes build time after everything merged to the Galaxy. And it would only could happen after you could deal with the node environment problems, because as GridSum was deprecated and no one were working on it, we had to hard code the versions of every packages we are using in Hub. And after a while, it also stopped us to extend the features, to bring the new things and so on. So the current build is less than a minute. And it means that every pages are just parse in a minute, and it means that you can just create a page, push it to the hub, and you don't need to get a break, and immediately it will live into the hub. So it's also we also improve the development experience, as we are using the HMR right now, hot module reloads. So when you are running the dev server on your local, you don't need more to revisit the development server, because everything are doing the HMR updates, and you can see the new things on local servers. So one of the most important parts that Galaxy Hive migration made us to do is that from now on we have a dedicated files and language system. I will explain it more in the next slides also. If you notice that most of the slides you saw during the conference, and also this slide, had the same styling and same background color and font styles, and all of these are now documented down in agents readable and humans readable content in a file. We call it DesignMD. It's based on the DesignMD protocol introduced by Apple, and every LLMs now nowadays can understand it, and then they can act as you to design the new things on behalf of in the Galaxy project. So we have a Galaxy Gold color used in most of the CTAs, important parts, highlight, and so on. As you may notice that, for example, the grid background here is one of the important things of this slide. And the font is Atkinson hyperlegible. It's really hard to read, honestly. So we are now using widely in every parts of the Galaxy, in IWC, Hub, and the slides here we have. So everything that we documented right now are not hard-coded. Everything are just using tokens, which means that whenever we decided to change anything on the brand token system design, it just need to change that token and publish a new package, and then everyone who are using the brand tokens will get the updates immediately. There is no new problems coming. So as I mentioned, the brand token is already published on the NPM registry. You can add it to your project, sites, and so on, and you can bring this new design system to your site and projects, and it's also readable for everyone. And okay, this one, microphone. Okay, sorry. So. What lessons we learned during this migration process was preserving behavior is always beats us when we wanted to replace the stack. So as Dan mentioned, choosing the stack was the easiest part, but how to plan to achieve this process was the hardest part, and we could finally did it. And then we had to document even the quiet dependencies. And otherwise, you have to document everything. Otherwise, you will see, or your user will see on the production level. So, and then we also as I said, we use that phase to never go dark. We use the running servers side by side to verify everything is working, and so. So this is definitely not the last migration of Hub, but at least from now on, we have every behavior, every part, and every action we took to be here are documented, and hopefully the next developers will appreciate it and can easily migrate the hub to the new version, to the new technology and frameworks. So at the end, we would like to say thank you. Thanks everyone who participated and who contributed to the hub. Currently, more than 210 people are actually contributed to the hub repo. And that's all. Thank you.
Thank you. I believe I'm the last talk, effectively. So it's a great privilege and honor. And as I'm also a newcomer in this community, I would like to just take a minute to say how happy I was to share these 3 days with you all, how much I've learned and hearing you share challenges, solutions, and ultimately values. So I would like you to join me in giving a big thanks to everybody who brought their experience here, and to the organization team. Jen, Enis, Natalie, everyone. Thank you very much. Also, I would like to say that as a newcomer, I've learned a lot today. What I'm going to share is how easy or difficult it was to integrate Galaxy into BRGM. We're still in progress. If I'm stating obvious things, if I'm talking about things that you've experienced before and heard before, I'm sorry about it. Please be forgiving with me then. So first, a word of the BRGM. BRGM is the National Geological Survey in France. So we're dealing with a lot of different specialties, domains like geology, of course, underground water, which is going to be very critical in the next few weeks, I believe, given the weather. Natural risks, natural hazards, and also critical resources like mineral resources. And so we needed a platform to, and I'm going to show you why. So geoscience, we've had a bit of presentation by Marie on Earth system. Geoscience is, as I said, covered many domains, many scientific specialties. Also, it covers a lot of data. It's something that you probably meet as well in your domains, but a lot of it in different forms of data. As I said, a lot of specialties. And of course, the same reproducibility challenges. I've seen this kind of sentences in many of the presentations this week. So, but basically, we need something to break the silos in scientific research. People looking for doing work with their data, with their methods, and not sharing easily what they're doing. And obviously, that's why we've chosen Galaxy. So last year, we started by installing our own instance of Galaxy without too much care for security or a lot of other challenges that we are now meeting, and I'm going to come back to this. One of the advantages of the first thing that the users asked at BRGM was, please, can you help us find our data? People had lists of Excel files with addresses that were mostly obsolete, where they would normally connect to try and get some data. So we've developed a module, which is the data access module, which helps us feed data into Galaxy through fair methods. I'm going to come back on it. We have a few special things in BRGM, and the fact that Galaxy adapts so easily to different modules was one of the aspects that we liked about Galaxy. And so I've set up a few specifics of the BRGM here. And we also at BRGM would like to, I mean, one aspect of it is the participation in national and European initiatives like the PEPRs, the exploratory projects, which are French thing. There are one in water, one on risks, and one on geology. And in every one of them, we've got to build a platform for scientists to share their work. And so that's another aspect that we wanted to bring into our projects. So I've already covered that almost with the previous slides. One of the big aspects of why we've chosen Galaxy is the existing community and the existing tools that we can obviously take advantage of, but also we hope participate in enriching. So that's why I've put the toolshed as an illustration for that slide. And also the modularity, I've already explained why we need to be able to adapt to BRGM and perhaps then contribute also to, again, bring solutions to the whole of the community. We've developed two modules. I've talked about briefly about the data access module. The data access module just basically reads catalogs. The catalogs are built on FAIR principles, which means they've got metadata around the data that is accessible through these catalogs. We're using both an internal catalog for BRGM data and external catalogs, which use some standard protocols that we can interact with. That's very practical. It's basically a search engine that helps you choose which data you want to download. And if it is in a standard service, you can actually filter it and take it straight into your history and use it in Galaxy. And the other element which we've developed is the Ghost. Ghost is basically a gateway that enables another application, a web application or another platform to run a workflow into your Galaxy using standard OGC API process formats, which means it's quite easy to integrate into another application or a platform. So the challenges we've met, and we're still meeting today. The first image, that's the way I thought it would go. As a project manager, that's the way I imagined. I'm not saying whether I was the dog or the shepherd, but I thought that's easy. I'm going to install a new tool and ask all the population of BRGM to come and use the new tool. And obviously, I found out that the second image is actually how it's going. They're giving me, the users are giving me a few reasons for their resistance into using Galaxy. One of them is the ease of use, but I don't buy it at all because frankly, most of them use much more complicated tools than Galaxy. And so I believe that the real reason is the second one that is quoted here. It's the lack of autonomy and control. And although they want to be able to take advantage of what others are doing, you know, if somebody has an interesting method, they would like to have it, but it is an effort for them to share, document what they're doing and put it out there. So it's very difficult to convince them to come into Galaxy. And that's why we've got a change management strategy, which is now in place. I've heard one of the presentation earlier. I don't remember very well, but I've noted it down. It was very interesting, and I'm going to apply some of the methods that were discussed here. The second big hurdle is the security, and especially the data security. Today, research institutes face challenges, cyber attacks, cyber security problems. Obviously, BRGM is no exception, and we've got somebody at BRGM that says, no, you can't do that. No, you can't do that. And at some point, it's a bit difficult to balance out what you want to share and what you don't want to share, how you manage to do everything. For instance, we've developed recently, I mean, I've got lots of examples actually, but a service that gives data about the I don't remember, drill holes forage. I don't remember the word in English. I should, sorry. And some of it is actually private, and we can't share it easily. So they held their hands, and even though we're using it in an internal platform today and not yet shared with the community, they said we can't have that. We can't have this service. So it's very difficult to, and we're going to work on this. And I would like to then advertise for a buff that takes place tonight with my colleague Martin Carrère, he's somewhere over there, about that. How do we install? That's something that we've met in BRGM. How do we install Galaxy in our institute? What falls onto our responsibility? What is Galaxy? What can Galaxy provide? Methods, questions to answer. Things that we probably all face in our different way. And we, as it says here, we also share the same questions. So it would be good to just perhaps have a word on that. So lesson learned. Well, it's an easy illustration. It goes into pretty much every PowerPoint presentation. We've got the tip of the iceberg is the technical implementation of Galaxy. It is challenging. There are challenges because obviously we've got different infrastructures in place. We need to understand how it's done. We've seen a few things again these 3 days that could help us potentially simplify the process. Bring your own device and lots of different new things that I've learned that I'm intending to work on. But the true, the big problems are hidden, and it's about governance, it's about change management, it's about sustainability, it's the human factor. This is really where the project is lying, the value of the project is. So I would like to conclude by saying that to us, Galaxy is way more than just a technical tool. It's a leverage for transformation of practices in BRGM, and it's a bridge between traditional, I'd say, science with silos, with desktop applications, with isolated data and methods, to a more open, fair, accessible, reusable, reproducible science. So thank you all.
Thank you very much, Pascal, for this presentation. Some question maybe? Nobody? Really nobody?
Thank you. Great, inspiring talk. About the previous slide where you had the hidden iceberg, my question would be about the governance. What were the governance issues you have encountered and how you solved them?
It's a tough question. Thank you. Well, some of the governance is actually, some of the answers are here actually with the IWC and the way we need to be, how to say, careful of what how we decide what we do, how we arbitrate between, for instance, data security or data openness. How do we manage groups of users, special projects which have very special needs, like the mineral resources inventory, for instance, which is a very, very big project in France, actually, and which have very sensitive data. So there's a lot of discussions and things that are not easy to solve.
I really like the talk, and I guess I also like the point that you make that some users feel like they give up autonomy. I mean, it's a point I made a long time ago, many times over, and it's also why the UDTs exist. Are there other things you could see where you could give back that autonomy to users?
Yes, I've learned again these 3 days. I've heard about this notebook thing. and Loom. I think that could go towards giving users more autonomy and making them work a bit more closely to what they're used to working with. We also try to automate things like, and I've seen some initiatives that way in these 3 days, how to wrap tools, make the tools from a string of code, an existing string of code, without the user having to make too much effort about it. So this kind of initiatives, and some of the new features as well, that gives more, I would say, more clarity into this left section of the of Galaxy. For instance, we're just rolling out version 26 in BRGM these days, actually. But I've seen a lot of functionalities that I'm interested in. Thanks.
Thank you very much. The last question from Peter. Thank you, Peter, because you are exactly at the opposite side of the room. So really, thank you very much.
So yeah, I've learned belatedly the lesson that you've got there in Orange. And I learned it as part of, I'm doing a master's in public health at the moment. And one of my modules was on health policy advocacy, because you can have evidence that's nothing without advocacy, right? Do you think that we as a community should be working on an advocacy toolkit or an organizational transformation toolkit to guide scientists like ourselves and software engineers like ourselves to be aware of these things, and what would you include?
Wow, that's another big question. I mean, this is completely new to me, but yes, I haven't. I mean, we've decided to perhaps participate first in this security side of things, because it's an immediate challenge for us. We really have hurdles to solve this year about it at BRGM. But yes, advocacy, governance, these are things that also we could benefit from the community if there was anything. I mean, that's my first answer. I don't have an idea how we'd go about it. But yes, obviously that's something that we didn't quite know. But also, I mean, I'm humble. I didn't take note of everything that exists in the community yet. There's way too much resource. You know, maybe I had missed something. So I wouldn't go about saying, it's sure for security, we need something. A broader subject, it's going to need some thinking about. But yes, it would help.
Thank you very much, Pascal. Thank you to all the speakers, and we can free Pascal because I'm not working.
All right. Well, good afternoon, everyone. So as we close the conference, I thought it would be fitting to kind of take a step back and look at Galaxy from a little bit of a different perspective. Over the last few days, we've heard a lot about the tools and workflows and infrastructure, training and scaling, and other community efforts across the Galaxy ecosystem. And of course, they're all incredible. But what I want to focus on is what all that work has made possible for science. So this talk is really about the research stories behind the platform. So the papers, discoveries, communities, and scientific questions that Galaxy has helped researchers to be able to answer. So Galaxy is often described through the things that it provides. So the tools, workflows, training, and compute. And these are the visible parts of the platform, and they're often how people first encounter Galaxy. But for this talk, I want to focus on what I think would be the next step or the results, which is the discovery. Because the story here is not that what Galaxy provides. The real story to me right now is what researchers have been able to do because these things exist together in an accessible, reproducible, community-supported environment. So the question I would like to address is, what has Galaxy made possible? To understand Galaxy's impact, I think it helps to remember the problem it helped to originally solve. Because modern biology became computational very quickly. Data became larger, methods became more software dependent, and researcher became increasingly data intensive, collaborative, and of course, dependent on reproducibility. But unfortunately, this shift did not happen evenly. Not every researcher had or has local access to specialized softwares and high performance computing or bioinformatics support, or the time needed to install and configure and maintain all those complex environments. So of course, this created a gap between the scientific questions researchers wanted to ask and the computational capacity that they had available to them. So Galaxy helped to close this gap. So it makes tools accessible, and it made workflow shareable, and it connected researchers to public compute. And of course, it created training materials, and overall it supported collaborative analyses. So in a very practical way, Galaxy helped to turn computational barriers into shared research infrastructure. So when we ask what Galaxy has made possible, the answer is not just easier analysis, but of course that matters. I mean, I use it too for research. I like that it makes it easier. But the larger impact is that Galaxy changes what researchers can realistically achieve. So access. Complex tools become accessible to people who may not have local computational support or command line experience. Workflows. Analysis become reusable. They can be shared, rerun, adapted, and of course taught. Results. Data becomes evidence to support scientific claims. And finally, discovery. Ultimately, science moves forward because of the discoveries made using Galaxy. So let's take this time to bring the focus back to the research for just a little bit. And to start that, I want to trace Galaxy's impact from the broadest view down to specific research stories. So there are many ways that we could measure impact, and of course, none of them are perfect on their own. Citation counts are really cool, but they don't tell the whole story, and same with publication counts, but they don't track workflows or training events or every data set analyzed or every person who's been supported by Galaxy. But for the purpose of this talk, I do think they give a useful window into Galaxy's research footprint. So I'll be framing this talk into 5 parts. How large is Galaxy's footprint in the scientific literature? Where is Galaxy's supported research happening? What fields are represented? And what did Galaxy help researchers to actually discover? And what made this possible? Of course, sorry, the community. So at the broadest scale, Galaxy's research footprint is actually really massive. So I was able to track down more than 23,000 citations for Galaxy across more than 15,000 unique papers. From work connected between 163 countries and territories and across more than 9,000 institutions. So of course, these numbers are really impressive, but obviously the story is more of what they represent. So these represent thousands of moments where Galaxy has entered the scientific process. So sometimes these are the primary analysis environment. Sometimes it's part of one step of a larger workflow, or maybe it's been from training materials and things like that. So when we talk about Galaxy's impact, I'm not talking about a small corner of computational biology. I'm talking about a platform and a community that's part of a research infrastructure for a very, very large body of science. So this map is a fun way to visualize Galaxy's reach. So each country here is, sorry, I can't even see it. I don't know. Each country here is shaded by the number of papers that have cited Galaxy, and then the points represent some of the institutions. It's only just under 3,000 institutions because plotting almost 10,000 institutions is a lot. And then the larger red dots represent the top 25 institutions that have cited Galaxy. So Galaxy supported research is happening across a global network of people and institutions, which is pretty cool. So the infrastructure and the tools and workflows and the training materials built by this community are not staying in one place. They move through our collaborations and publications and tutorials, workshops, public servers, domain communities, all that fun stuff. So let's look at that global reach a little more closely. So we have 163 countries and territories represented. And the top countries by percent of unique work include the United States, Germany, the United Kingdom, France, China, Canada, Australia, Italy, Spain, and the Netherlands. And of course, these percentages, they're not perfect, right? They don't exactly represent perfectly who uses Galaxy or who is best benefiting from it. But even with those limitations, I think the pattern is pretty cool to talk about and pretty clear. And that's that Galaxy supported research is not confined, right? It's really part of a global research ecosystem, and that's pretty cool. Yeah. So the same pattern shows up at an institutional level. So we'll look at that real fast. So I was able to identify more than 9,000 unique institutions that have cited Galaxy. And the top institutions include national research organizations, major universities, biomedical research centers, and institutions with strong computational and life science programs, which I think is really fun. So Galaxy is being used across a wide range of research environments, from large computational centers to smaller labs, and across institutions focused on many different kinds of scientific questions. So we're going to look now a little bit at those fields that are being represented. So the largest category here is genomics, genetics, and other omics. And that, of course, makes sense given Galaxy's history. But the footprint does expand well beyond that. So we see microbiology, virology, infectious disease, of course, computational biology and the data sciences, biomedical and human health research, plants, agriculture, food systems, ecology, evolution, and environmental research, which I am particularly fond of, molecular and structural biology. And then we do have a substantial other category, which I think is really cool. One thing I found while preparing for this talk was that probably the neatest paper I found was actually a medieval archaeology paper that cited Galaxy, and it is the only one from the archaeology category that popped up. So that one was pretty cool. So I like to think that this shows that Galaxy is a model for making computational research more accessible and reproducible through many, many, many scientific domains. So this kind of leads me into the next part of the story I'm hoping to tell here. So if the numbers show the footprint, to me, the next question becomes, how does that footprint continue to grow? How are we growing? And one answer is through scientific ecosystems. So communities that build around Galaxy and turn individual tools into reusable research infrastructure. So before we zoom in and take a look at some individual papers that I have found, I want to highlight a few examples of Galaxy-centered scientific ecosystems. So these are communities where Galaxy's impact is not just one analysis or one workflow, but it's the overall development of tools and workflows and trainings and all that to support many studies over time. So we've heard from quite a bit of them at GCC this year and obviously previous years. But I did want to take a moment to highlight a few of them. So these are just a couple of examples. I know there are many, many, many out there, and I'm very grateful for all of them. So I just wanted to show a couple of them and zoom in very quickly on each of them. So of course we have to start with the infamous Vertebrate Genome Project and VGP. This is a global genome initiative working towards high quality reference genomes for vertebrate species. And in this context, Galaxy helps make high quality genome assemblies accessible beyond specialist genome centers. So of course this matters because reference genome generation is not just a one-time analysis, right? It requires complex and coordinated and repeatable workflows that can support many species and many different research groups. They're even helping me with an invertebrate right now. So I'm just saying. And then of course we have Elixir Galaxy. Elixir Galaxy is another example, but this one kind of connecting public compute and tools and workflows and training and community infrastructure across Europe. So I think this one is a good example of Galaxy as shared research infrastructure across borders. So because we looked at that map showing our breadth and where we are, and Europe is very, very populated there. And I think part of that is because of communities like Elixir. So it's connecting people, it's connecting the platform, and of course it's connecting expertise across the institutions as well. And then we have a Galaxy P, which I don't think was talked about here. Maybe it was, but Galaxy P shows us how a domain community can bring a highly specialized methods and make them into accessible workflows. So proteomics, proteogenomics, metaprobiomics, and multi-omic analyses are very, very technically complex. And of course, they're software intensive as well. And so Galaxy B helps to turn those methods into workflows that researchers can run and share and inspect and teach with each other. And of course, we have the Galaxy Training Network. And I think the GTN is probably the clearest example of Galaxy as a learning ecosystem. It is not just documentation. It's just not the tutorials that you see online, although they are impressive and very fun. It is a community-built training infrastructure that lets researchers learn computational methods by doing real analysis in Galaxy. Training is one of the major ways that an infrastructure becomes useful. a tool that nobody can learn is not accessible in practice, right? So the GTN helps to make methods usable and teachable and reusable. And then we have microgalaxy. So microgalaxy is a specific community to support microbial and microbiome and metaomics communities. So it brings together curated tools and workflows and trainings so that researchers can carry out microbial and microbiome analysis in ways that are more accessible and reproducible in Galaxy. So across these examples, the details are all a little different, right? So the scientific fields are different, the methods that they use are different, and of course the communities are different, but the pattern is definitely the same, and that is that Galaxy becomes more powerful and powers more discoveries when communities are building around it. So what do these ecosystems have in common? They show that how Galaxy becomes more than a platform. It becomes shared infrastructure for doing science. Tools become maintained methods, workflows become reusable standards, trainings become community knowledge, and infrastructure becomes shared scientific capacity. So having gone through all that, sorry, I was kind of long-winded. I know you're all very hot. I feel like we can now ask what specific science has Galaxy made possible? So I'll like to take this moment to quickly zoom in onto 5 papers. The 5 examples are not meant to be any one more important than the other or anyone that's not mentioned, of course. I'm not trying to rank Galaxy papers. Please don't think that. They are examples of different ways that Galaxy has played a role in the scientific literature, though. So not to get too long-winded, I'm just going to focus on 3 main parts for each example, and that is what was the research need that inspired the paper, what role did Galaxy play, and what larger insight does that give us about Galaxy's impact? So I just want to start with one of the, and there are some people in the audience that authored these papers, and I did not realize that, so hello. I wanted to say, so one of the clearest examples is Galaxy as a public scientific infrastructure. So we all remember COVID. So during the COVID-19 pandemic, sequencing was essential for tracking viral evolution and monitoring variants as they arose. But the need for analysis was urgent, and it was global, of course, but it was also unevenly distributed across computational settings. So Galaxy provided basically like a ready-to-use public infrastructure for COVID monitoring. So this included things like compute access and validated workflows and analysis interfaces that public health organizations and other research groups could use without having to build everything locally or from scratch. Excuse me. So this is Galaxy at a crisis scale. So it basically shows to me how infrastructure can support speed and reproducibility and access and coordination when science needs to move quickly. And the next story here focuses on more on how cancer evolves over time. So this study brought together clinical history and treatment timing, molecular data and imaging, and spatial single cell information, all to understand how metastatic breast cancer evolves and responds to different therapies, or to therapies, sorry. And so Galaxy supported a multi-step workflow for raw omics here and imaging data sets. So this helped to turn many layers of complex data into analysis that could be organized and inspected and reused. So this paper highlights Galaxy supporting high dimensional biology, where the challenge is not just generating the data, although I'm sure we all know that generating data can be very complex and difficult, but instead by connecting different kinds of data in order to tell a biological story. And so the third example kind of is going to move us more into structural biology and AI-enabled protein sciences. So here, AlphaFold was used to assess leucine zipper constructs. So basically asking a question that is becoming increasingly important in protein design and other AI things is, when are confident AI structures predictions actually biologically meaningful? So Galaxy Australia provided access to AlphaFold 2, which allowed researchers to model synthetic peptide variants without managing GPU infrastructure themselves. So this broadens a Galaxy story beyond just genomics. It shows how infrastructure helps researchers using advanced AI-enabled methods to perform experimental, to methods in practical experimental contexts. And the fourth story shows that computational genomics can raise questions beyond discovery alone. So I really like this one. I'm a big fan of environmental DNA. So environmental DNA has become a powerful way to detect organisms and traces of water traces left behind in water and soil and air and other samples. We heard a little bit about it in I think 2 talks at GCC this year. But this paper asks a little bit more of a complicated question, and that's what else are researchers that are using eDNA capturing? So Galaxy and NanoGalaxy supported processing of short read and nanopore eDNA data, including things like quality control and trimming and alignments. And the important message here is that important Galaxy message here is that accessible workflows can help emerging fields examine their own consequences. So in this case, the analysis helped address concerns about privacy and consent and governance questions about human genetic information that are appearing in these environmental samples that researchers are collecting. And the final example brings us into plant science and research and back to kind of applied genomics. So this paper generated high quality genome resources for 2 cotton-associated isolates, each supporting research into strain variation, pathogenicity, and disease biology. So Galaxy was used across basically almost the entire genome workflow here, everything from read processing to mitochondrial assembly to nuclear genome assembly, filtering, annotation, and then the comparative analysis that they conducted. So this is a really clear example of Galaxy as an applied research infrastructure. So it shows Galaxy-supported genomics helping turn advanced sequencing into practical resources for something bigger. So in this case, for food systems and plant disease research and applied government sciences. So these 5 papers are scientifically very different, but I hope you saw that across all of them, Galaxy role repeats. So I hope these examples help to show what I've kind of trying to highlight throughout this talk, and that is that Galaxy creates access and it supports reproducibility, it supports scale, and it supports community, and overall it supports scientific discoveries. And of course, these 5 papers do not tell the whole story. They're just 5 examples I chose to talk about to show the range of science that Galaxy helps to support. But one of the fun parts of working in Galaxy Communications, for those of you who don't know, that's me. I'm the one that you guys talk to on email and stuff. Is that I get to I take the time to look at these research insights pretty frequently. So papers using Galaxy show up in genomics and environmental sciences and public health and biodiversity research and all those things I talked about earlier, and other ones that I never would have expected really regularly. So I'm signed up for alerts when the Galaxy paper is cited, and I receive multiple emails a week of people citing Galaxy. So it's always fun to take a look at. So I like to highlight them. I highlight them on social media. I also highlight them every Galaxy newsletter as well. So if you like learning about these things, take a look at those, and you can always see what I'm highlighting that week. I try to keep, that quarter, I like to keep it active. So this is also an open invitation that if you know a cool Galaxy paper, yours or a student's or anything like that, or just something you found, please send it to me. I'm always happy to read it. But after all those examples, I do want to just take a moment to briefly highlight that Galaxy has a new paper. So that means we all have a new paper. The 2026 Galaxy update was just published in Nucleic Acids Research. At a huge thanks to Scott Kane for picking up a lot of that work. So if Galaxy supports your research or your teaching or your trainings or anything like that, please cite the new Galaxy paper, the 2026 one. But to bring it kind of back to the focus of the talk, I do hope that you can see that Galaxy's impact is bigger than you maybe realized coming into this. The legacy of Galaxy really does build across scales. So it starts with individual analyses, though those results can become part of a published paper. That paper has a workflow in it. That workflow can become reusable, and then over time, that can become a community resource. And then at the largest scale, it ultimately has the opportunity to become scientific infrastructure. So Galaxy enables many questions across many different fields, and that is what makes it this different than thinking only about the impact as a publication count or a citation count. Because the real impact truly is cumulative. It builds on analysis, is becoming papers, and papers pointing back to the methods, and methods then become workflows, and workflows become trainings, and trainings become community knowledge, and it's all shared across borders and over time. And so this is how Galaxy Legacy grows. It does not stay in one place, and it grows across many, many layers of the scientific process. So that brings us to the community, the Galaxy community, because tools alone do not create scientific impact in a way that research like this does. A tool can exist, but if it's not maintained or documented or taught or supported, the impact is limited, right? So the impact comes from the people who make the infrastructure usable, the people who maintain the tools and build workflows, who teach methods, who support our users, who run servers, who write documentation, and people who organize communities. If I forgot anything, I'm very sorry. I do think this is especially important to say here at the Galaxy Community Conference, because so much of Galaxy's research impact comes from work that is easily overlooked, right? So, because not every contribution becomes the title of a paper, and not every contribution shows up in a citation count. But the person who fixes a tool wrapper or updates a tutorial or answers a user's question, reviews a workflow, maintains a server, organizes an event, it's all part of the research infrastructure. And that is why Galaxy's research footprint is truly a community achievement. Galaxy is a community-built infrastructure. That infrastructure helps to lower barriers. Lower barriers change who can do the computational research, and that makes more science and more discoveries possible because of Galaxy. So Galaxy's legacy is not just a platform. It is the science and the workflows and the communities and the discoveries made possible by the shared scientific infrastructure that Galaxy has been able to provide to so many people. And that is the message I do want to leave you with as we start to close out GCC this year. I also want to say thank you. Thank you for building the tools, for maintaining the workflows, for teaching and writing tutorials, for supporting users, for running our servers, and for organizing communities. But mostly, thank you for powering scientific discovery with Galaxy.